I love that. Well, thank you, everyone. Welcome to Conversations for the Future. It's wonderful to see everyone. Today's topic is workforce and industrial base. I know that sounds a little stuffy, but I promise you this will be a very fun event. I wore my kind of casual t-shirt here, just, not wearing the suit, just to keep it real. So yes, if you're joining us for the first time, this is a monthly event that we host. We being Foundation for the Future, we like to host these so that we can get together a lot of thinkers in the space industry and have conversations around how we can advance space access for everyone and do so in a way that really focuses on the near term, near Earth. What are the real sort of nuts and bolts tools and tactics that we can use to move us closer to thriving in space. A little bit more about the foundation. We are a 501c3 education and advocacy nonprofit and the only nonpartisan organization advocating for financial tools that will make it easier to get capital for space infrastructure. Again, that sounds a little stuffy, but we're here to make this fun. And at the end of the day, our goal is space access for everyone. So today, Tim and I are just going to start by talking a little bit about what we're trying to do here and actually celebrate our 1-year anniversary, which is hard to believe. We've made a lot of progress in the last year, and before we start the banter, I just want to take a moment to recognize Tim Chrisman. He is our founder and executive director, and I have yet to meet anyone as committed and dedicated to anything in my life. So much passion, so much energy, and really just, he's put more or less everything he has into this, and it's very admirable. So Tim, I'm sure you'll get an introduction at some point later, but thank you for all you've done. You've inspired me. I've learned a lot from you, and just thank you for taking us all on this journey.
Thank you, Lila. I don't often think what I'm talking about or doing is weird or unusual, and I have found that's pretty much all of us when we're doing whatever it is we're doing, especially if it's something we've done for a while. We tend to miss the difference it might be, and I know a lot of times I talk about how one of the things we're trying to do is build the systems and processes elsewhere in the federal government so that NASA can get to pushing even further in exploration and making the impossible look easy. And I like using the example of making me feel bored as Mars landers come in for sort of one-shot landing straight from Earth. And I'm like, yeah, whatever, no big deal. Turns out it is a big deal. It just looks easy when they do it so well. But yeah, it's been an amazing year, and I know, over the course of this year, you and I have sort of at times not really been sure how much traction, where this is going to go, what's going to happen, and here we are, a year later. Leah was building us some stats for me to use next week for my update. Something on the order of 80,000 followers across social media, and we've got north of 100 people in Congress supporting our Space Corporation Act. We've already got language in defense authorization and appropriations bills. It's been a pretty good year. This is, I think, the 9th of these events we've held. Hundreds of speakers, tens of thousands of people have watched the events live or asynchronously, and all with the single goal of making this routine and making it look easy, making space accessible. And I'm excited that we've been able to have this sort of impact so early. It's really cool, and I think it's in no small part a testament to people like you, Leo, who have been here from the beginning, Michael and Lee, for their work building conversations into what it is now. This is has its own life, and it's really cool to watch it grow more and do so rapidly. One of the things I like most about anything we're doing, but the conversations series in particular, is that we don't have to get it right one time a year, like most major conferences. We're doing this 12 times a year. And so we're going to get better every single time, and have been. And I think that the viewers get to see that the quality of not just the presentation and how this looks, but the speakers that come in with the variety and depth of knowledge, and then how Lee has adapted this and added in new segments, new features. I think I'm really excited to see where she takes this next.
Yeah, I agree. And not only are we trying to make space accessible, I think this event needs to remain really accessible. We don't want to exclude anyone from understanding what's happening in the conversation. And I think that's really worked to our advantage. My godmother tuned in last month, and she's worked in education and learning her whole life. She lives in San Diego, and she thought it was the coolest thing ever. And she said, I had no idea what the potential of space was. I had no idea what companies were doing out there and the conversations people were having. And I think we just have to continue to bring more people into that fold, because the more people who understand the potential of space, the more people will want to get involved and see what's in it for them. And maybe nothing, but for those people, and I think there are a lot of people in the younger generation who maybe have an interest or, a mild fascination. And until that there's a real path there for you, I don't know that you're going to really entertain it. So I think what you're doing, especially with workforce development in early education, is huge, among many other things. But
no, and I think you're right with the accessibility piece. We set out for this to be sort of the neutral ground between those practitioners and the general public, where regular words can be used. There's no need for jargon, for sort of determining who's in, who's out through the use of the terms and language that we're using as we talk about this. And it's not out of some sense that we need to dumb this down, and it's not out of some sense that we need to pander, but it is entirely because the words we use and how we talk about it, we do it unconsciously to signal whether we're in or out of certain groups. And we all do it to some degree. And the whole intent with this, coming from people who have spent their lives throwing acronyms around for fun, is to demystify a lot of that. And so nobody feels like anything's going over their head, and taking a few extra minutes to just level set. And I think that is turning into a really awesome forum where, the practitioners get a chance to explain what they're doing. And, people like your godmother get excited because maybe for the first time, some of them feel like they really understand because they had been turned off by a lot of the language previously.
Yeah. Well, and I think a lot of it just isn't visible.
Yeah.
I think that's also part of our objective, is just to make it visible. until people see that space is a viable option, they don't see it as such. So keep having the conversations, keep doing the work we're doing, and I think we'll attract the right people. I've been fascinated by how many people have come to me. I don't come from the space industry, but a lot of people seem to be attracted to what we're doing because they are maybe in an industry that they're not loving, or in a job that they don't feel fulfilled somehow. So having people come from other industries into the space industry, I think is really cool. And the space industry needs that. So
Oh, yeah, yeah. No, we are definitely at a point where we need that new infusion of ideas from adjacent and completely outside the normal sort of areas, not just to shake up what's being done, but also because we're starting to move into things that are not just physics and science and exploration focused, but it's manufacturing, it's living, it's sociology. It is things that we've thought about and talked about and has been the domain of science fiction in many cases for a while. But now bringing those people in with their new perspective and being able to hear their thoughts and ideas is what is going to keep the momentum around this industry going as much as new capital will.
yeah, yeah. Well, and on that note, we want this to be a conversation. So at any time, feel free to drop a comment in the chat or a question, and we look forward to the dialogue. So we've got about 1 minute left here, Tim. What do you feel is the greatest accomplishment of the year so far? And what are you looking forward to in the next year? What's your big...
I think the greatest accomplishment has been it's been getting workforce development language into the FY22 defense appropriations bill. That is often a multi-year process trying to get new text in there, and we're able to do that this year. And that was, the better part of half dozen of us working long hours and the phones constantly. And so I think that work really paid off. I'm really excited for the next year to see how, as our membership continues to grow and we remain laser focused on the Space Corporation Act, which we'll get into later during this event, how that goes, where that goes, what changes. It's already on version 39 or 40, but as it is introduced, how does it change from there? So, yeah.
Great. All right. Well, thank you, Tim. With that, I will pass it to Lee Steinke, who has put together a phenomenal event for us. So please enjoy the ride. To see the lineup, go to f4f.space/conversations. That's where the agenda is. I'll drop it in the chat as well. But Lee, please, I pass it to you.
Thank you, and happy birthday to Foundation for the Future. It's great to hear you all reminiscing a little bit and talking about our accomplishments, and it was really fun to kick this event off. Our first speaker is Pete Wilczynski. Pete is currently a program executive at NASA headquarters, a U.S. Air Force veteran, expert in interagency and international collaborations in space system acquisition and development, satellite ops expert, NASA HQ's ombudsman, and aviator. He has over 34 years of U.S. government service in military and civil remote sensing satellite design, development, launch, and on-orbit operations. Pete is acknowledged as a leader in highly complex joint agency and international satellite programs and has earned some of the highest leadership medals in the U.S. Department of Commerce, Department of the Air Force, and NASA. Pete, it's such an honor to have you here, and the screen I'm going to share for you so that you can talk from your slide.
Great. Can you hear me, Lee?
You sound perfect.
Great. Thank you, Lee, for that introduction, and congratulations to the foundation. Great set of introductions about the foundation. Something that really resonated with me was a conversation that you were having earlier on about the sort of the middle ground between those of us who use the acronyms very freely and have so for the majority of our careers versus the taxpayers and the people in the community that we're trying to serve with space systems. And it was one of the early mantras of a mentor of mine was that, if we can't explain what we're doing in space down at the corner Starbucks, then we are missing the mark on what we're trying to do. If we've made it overly complicated, then we're really truly missing the mark. And so that whole concept resonates with me. So thank you for the foundation. Congratulations on your birthday. I sincerely appreciate the invitation to have this conversation for a few minutes here today. And I certainly welcome any questions along the conversation this morning. As Lee said, I have a fair amount of scar tissue of working in the government for the better part of 35 years. I've done a variety of different jobs, been program manager, project manager, program executive, of all the rest. But today's conversation is about what's happening in the workforce, and I will share with you my perspective, and that is it. It is my perspective only from the contract teams and the supply chains and the partnerships that I have exposure to, and I certainly along this conversation would welcome any of your questions. So if you have questions, please enter them into the chat, and Lee I know is going to help me navigate that the Q&A as we go. So thank you for that in advance. So, one of the questions that everybody asks is, so where is the industry here a year after this pandemic? And, I might have answered this question a little bit differently back in June. And now that we're sort of, in a way, revisiting some of the, entry level things that we kind of had to cope with as a nation heading into the pandemic last year, we're kind of facing a little bit here in the last few weeks. And I will say that the industry has done a phenomenal job adapting to and dealing with the complexities of this pandemic. If there was ever any doubt, not only about the American aerospace industry, but the aerospace industry globally. Last year, the total value of the aerospace industry was projected something on the order of nearly 300 billion, dollars, US dollars in market value. And, current projections, even based on this year, are looking at a market value going up to nearly 450 billion by 2025. So the industry is vibrant, and it's evidenced by not only the market value, but how the industry has reacted to dealing with a pandemic that has affected every single person that you can imagine, from the CEOs of these companies to the technicians on the floors putting together circuit boards and electrical connections and batteries and solar arrays and everything that we can imagine that goes into building a spacecraft. It's been a tough year, and the year was punctuated not only by a pandemic that none of us could have even imagined. I was recalling just the other day with colleagues that when they told us at NASA headquarters that we would have to telework for 2 weeks, I didn't think I was going to be able to survive 2 weeks of telework. Being an extrovert and being somebody who accomplishes most of my work in a very socially dynamic way, I could not have imagined how I could survive 2 weeks of telework. And here I am entering year 2 of telework. We all had to adapt. And the year was punctuated by geopolitical events that tugged at our heartstrings and changed the political environment, and a fair amount of uncertainty roped into all of that. A fair amount of uncertainty about not only is where we were going as a nation, but where we are, who we are, how we're working together as a global community. There was a fair amount of head scratching. At the end of the day, I would say we continue to march forward. And I offer you my opinion from the perspective of working with a select group of industry teams that do in fact support NASA, and my direct exposure working with them daily, is that the industry adapted to sort of unforeseen complexities of being able to put together complex multi-million, multi-billion-dollar spacecraft systems, with a workforce that also had to adapt, and a workforce that, by the way, in many ways was affected, and tragically in many ways affected, with people that did not survive getting COVID early on in the early part of the pandemic. And as that affected every part of our society, it also affected the aerospace industry. There were a lot of things that changed and had to be changed in order to continue this success and continue the viability of the industry. And one of those things that really happened was, I would say, I observed changes in the supply chain, if you will. And, we noticed, you would hear most of the national networks and many of the local networks all talk about, the fact that how groceries were coming to grocery stores in the first few months of the pandemic, and how there were disruptions in transportation and the supply chain. It became an in vogue term used by the common citizen of the U.S., a term that they normally wouldn't use in any sort of conversation we use in our industry and you use in a industrial base conversation. You hear those terms, but all of a sudden there was conversation about the supply chain and what does that mean, and how trucks and produce and whatnot was making it to the grocery stores. Here in the aerospace business, we're facing some dilemmas with the supply chains. One of the things that we became very aware of in some of the programs, and the programs specifically that I work on at NASA, was even the smallest component that would fit inside of a box that would be part of a bigger box, part of a bigger box, part of an instrument that would go onto a spacecraft. If it was in fact made by a small manufacturer somewhere that was not, did not coexist in either the location where I live here in Washington, but perhaps somewhere else in the country that was differently affected by the pandemic, what we noticed was production slowed. People were not willing, obviously, early on to go back to working shoulder to shoulder in a laboratory or in a production sort of environment without knowing their exposure rate to the pandemic, and therefore production of circuit cards or batteries, cable harnessing, all these types of key elements that put together a spacecraft had slowed. And in some cases, some of the smaller, if you will, mom and pop kind of organizations that would produce and have produced these key components for space systems for many years found it hard to survive, and some did not. And so the supply chain had to adapt. NASA had to adapt with its contracts and industry teams to figure out how do we get those key components that are vital to these systems. And we did. And vendors surfaced that were able to either work remotely or have specialized teams that were socially distanced in environments that their companies provided that were appropriately ventilated, with appropriate separation and appropriate medical measures to make sure that their employees were safe. That was an adaptation that happened that we would have never considered, a year or two ago. But the companies did, and therefore they produced these elements, and they kept major programs such as mine, the Joint Polar Satellite System, on track. And that adaptability is not a one-hit wonder, if you will, that may in fact, lead itself to other efficiencies. We talked a lot in our industry about robotics and remote monitoring and the ability to conduct inspections. NASA. I know many of you will find this very hard to believe, but NASA is very in tune with having, if you will, boots on the ground with our teams, engineering teams, witnessing the production of certain things. Do a lot of Q&A, quality assurance types of activities at the factory when things are packaged, when they're shipped, when they're sent, when they're received, unpackaged, plugged back in. NASA is there all along the way. And in fact, that's been a key component of much of our success, is that due diligence that we provide to what we do. That works for us. It may not work for everybody, but in fact, that sort of discipline is inherent in what everything NASA does. However, if you imagine this last year, we could not have boots on the ground. We could not have put people, government employees, at risk to witness, fly with, be there on the loading dock, have things opened up. We could not be in these locations and do this. So how did we do our job then in this? And so we adapted. We adapted with using our phones, our laptops, and remote devices to witness things in different ways that wouldn't have never been imagined that we could do, or even accept. And acceptance, personally, as an agency, and personally accepting the fact that we could look at something on our phone, or through FaceTime, or through Zoom, or through Teams, or through Google Meet, and accept it as we see it and say it's okay. That's a page turn for NASA. That's something we would have never accomplished. Always in person, touch, feel, see, talk to is what we have done. And of course, this year has not permitted that to happen in large part. So the change happens everywhere, and it did across the supply chain, and it changed a lot about how we behave as well. And although I'll say, earlier this morning, I was talking with a series of young engineers from a company in Europe, talking about the woes of the pros and cons of being in a new startup company, aerospace company, and how exciting a new startup is, and yet based on their success and burden of new employees, how the company is slowly losing its agility, which is what attracted all the young people to go and be a part of this startup. And that's sort of the cycle of life in the industry as a startup, but also the cycle for companies and institutional entities such as NASA. NASA, to institute change is, as you would imagine, a huge bureaucratic uphill climb. It's the moral equivalent of doing a 3-point turn with an aircraft carrier in the Panama Canal. It's just not going to happen very fast. And yet, NASA can change, and NASA does change, not as quickly and agilely as industry and many of our partners in the private and public sector. But it does, and this is this event that I talked about in terms of how we inspect and do our QA functions has evolved and has changed, and I would contend that it will change from here on out how we continue to do this. We've determined that it is not essential for us to be everywhere at all times to see these things happen. We might be able to do this completely remotely, and that could lend itself to save travel funds and things like that. So. It is it is a long process, and it is part of the strength of the aerospace industry is the ability to respond to change and to adapt. And although, like I said, we started this conversation a few minutes ago, although many industries across the globe have not fared quite as well, the aerospace industry is coping fairly well and continues to do very well. I might pause here for a second to see if there are any questions or any comments to that end before I chat about a couple of other topical areas.
We just had someone comment that your comments are very true. Technology is so important, and that this outbreak made us all adapt. And hearing about a large bureaucracy like turning an aircraft carrier in the Panama Canal is certainly a good description of that.
Yeah, it's not pretty, but it does happen.
How much do you think NASA has saved this year in travel costs related to QA in factories?
Well, that's a fantastic question. Yeah, I don't know quantitatively what that is. I imagine it is a fairly sizable number, and I will say it has to be substantial because NASA does. We spend a lot of time on the road with our industry partners, building, delivering, launching spacecraft, and not only within Earth orbit, but within our solar system and even outside of our solar system. So there's a lot of travel. I imagine probably after the next year or so, there will be a lot of, if you will, post-pandemic statistical analysis that will show, really where the knee in the curve was for all travel and all those things without, and relating it to mission effectiveness, realizing that, NASA, our industry partners, and all the multitudes of supply chains. I read somewhere that supply chains in the aerospace business is somewhere on the order of 25,000 different companies that supply elements to the infamous supply chain for aerospace. We will see that they were highly effective and successful with very limited travel. So I imagine we'll see some pretty interesting statistics when we get around the corner finally around the pandemic.
Yeah, and can you talk a little bit about what an ombudsman is briefly? And then did you see any complaints related to these changes in bureaucracy, process, supply chain as a result?
So great question. So if those of you who are not completely aware of what the word ombudsman is, the word is actually a Swedish word. It came at the turn of the century, and it basically relates to somebody or some entity that will, provide the ability to listen to and to help. In this case, my role at NASA is to help employees, whether they're civil servants or contractors or support team members, to help anybody who has a concern, personal or mission related, without the fear of retribution, right? In fact, at NASA, the Ombudsman program was established shortly after the Columbia accident in early 2003, where it was discovered once again that complaints and concerns for safety of the shuttle and its astronauts and technical concerns that were shared, they were not forwarded for fear of retribution. And so the NASA, as part of the the Columbia accident investigation report, part of that report established the Ombudsman Office at NASA, and we have 25 ombudsmen across all 10 NASA centers, basically 2 at each center, and I'm at headquarters and I manage the entire entity for the agency. And this allows, again, employees to, in a private and confidential way, surface issues that concern them, again, without any sort of retribution. And this strengthens that desire to do the right thing and not to allow us to look away from things that inhibit safety, in particular in human spaceflight, but in safety to all of our space systems. So it's a very successful program. Now, your question about, in this last year, has it been exercised? Of course, just like, every other group of employees across the globe, there's been a stressful time. And there's a lot of stresses and a lot of concerns, and remote working has been challenging on a lot of different levels. So we've seen it. We've seen it with contractors have exhibited issues. Not all industrial or private companies have that sort of same type of program. Many do. Many do have sponsored ombudsman programs. They actually have professional ombudsmen that do this, if you will, full time. We're a volunteer force that does this in addition to our daily duties. So it is sort of a give back to the agency, but it does allow the agency to continue to strive to do the right thing, and also to continue to be now 6-7 years in a row the best governmental agency to work for in the U.S. So it continues to keep employees satisfied and safe in the workplace. That is what we all try to do.
Thank you so much.
Sure. So I'll go ahead and move into the next segment maybe a little bit and talk about innovation. And it's unbelievable how innovation continues to come at every twist and turn in our business, in industry. And one of the things that has been on the forefront of all the publications and if you will, the industry periodicals is the launch business, the launch services providers. And looking just recently at some of the U.S. News statistics, there's something like 110 different launch services companies across the globe that provide various levels of launch services. And if you think about access to space, period, and there's 100 companies out there that could provide access, it's a pretty robust market. And the innovation is really coming in many different forms. I mean, again, going back to the conversation down at the corner Starbucks, most people can most easily relate to what they see in media, which is, obviously either United Launch Alliance or SpaceX or Virgin Galactic or Blue Origin, in terms of some of the headline capturing events that have happened, even this last year, even during the pandemic. And yet the launch business continues. And there are, from the Czech Republic to China to Germany to the US, there are companies that are spawning everywhere that are looking to wedge themselves into the market. And therefore it's making the market a very robust place. People are generally, again, back at Starbucks, commonly unaware that SpaceX's journey is not something that just happened in the last year or two. Their journey began 15 years ago or more, and their successes were hard fought with several catastrophic failures, and many of us remember seeing video of a on-pad catastrophic failure, and they recovered from all of that, obviously, and their strength was in that recovery. And now we're watching them put humans into space pretty routinely. So people forget that these journeys take quite a long time. But there's innovation in fuel systems and in engines and in production and in access to space. And this is pretty exciting for those of us who are talking about access to space and commonly looking at this in terms of a community. How does a university or a research organization have access to space? It's a bright future in terms of innovation in the launch sector. There's a company called Relativity that has one of the strengths, besides its unbelievable amount of private investor funding. Their strength is they're going to be building rocket engines on a 3D printer. And if you think about that concept and think of where we were about 10 years ago, thinking about a 3D printer, you would have looked at a pen being manufactured by a 3D printer, but probably not much more than that. Now if you're talking about a rocket engine and several rocket engines being designed by a 3D printer, it's that kind of innovation that actually is going to make that part of the launch services very intriguing. And I say this only not that I'm picking sides or picking vendors or industry partners in a certain way. I think it's important to be aware for the connection points, as the foundation spoke early in the introduction, the connection between those that are doing this and those that want to get there, making that connection in between, the awareness of knowing what is out there and the fact that the market is not only surviving this pandemic, but is growing quite well. And this particular, one of the hardest and most expensive elements of space system and budgetary planning is access to space. It's conceivably going to get easier, more flexible, more agile, and because of the marketplace, fundamentally more economical. Again, having managed several large programs in the U.S. government, that launch part of your program's budget is usually so profoundly large because of what we, as the government, require to fly payloads. I can imagine an industry looking at getting 6, 7, a dozen smaller payloads onto a rocket, maybe even in a rideshare capacity. Somehow, when you divide by n and you get to a number that is actually all of a sudden, and I'm making this up, but it's $12 a kilo or something like that, suddenly that's a viable solution for access to space. And now that introduces the ability, globally, that any university, small research center can viably get access to space in an economical fashion. That's pretty exciting. That's pretty exciting in terms of turning points. And there's been a fair amount of skepticism associated with that in the marketplace, whether or not everybody and everything is going to survive. Will there be 100, 1, 2, 3, 4 years from now? No one can say that, but clearly the fact that there is 100 is pretty significant in my humble opinion. And the fact is that the number is in fact growing, and it is exciting. We talk about it quite often at NASA. In fact, we talk about it every month. In fact, I will be talking about it Thursday morning, with our colleagues down at Kennedy, about how the forecast is looking and how these vendors are going through their demonstration phases and getting into the market, and what's the price point. This is important. This is an important part of our ability, because again, building the unique elements in a space system or a capability on the ground is clearly one important part of this. But getting it onto a rocket safely and getting it into orbit, that's where the money is made, and this is where revenue can be received from things that go on orbit, whether it's commercial communications or otherwise. This is how revenue can start. This is how business can start. That ties the whole link together.
It's so exciting to hear that you're seeing new vendors, brand new people coming into the market, in addition to the ones we hear about on the news. There is a link that Kevin Russell has put in the chat for people to enjoy, Space Tech Industry in Figures, and a couple of additional comments. I do agree with you on SpaceX. They worked hard and had many failures before becoming famous and successful. Just as we wrap up, I wanted to ask you just one brief question about international collaboration
Sure.
through the pandemic. You're an expert in that. What kind of changes have you seen in that program?
That's a great question. Have seen very little change because we all had to adapt in almost the same way. So we all had to face the telecommunications changes that we had to make, and all of our respective meetings and so forth. Again, the industrial base internationally had to adapt the same way our U.S. industrial base had to adapt. So it's been fairly consistent in that sense. And I would say almost equal in terms of our collaborations. All the international collaborations continue quite well. I'll point to NASA's flagship mission, the James Webb Space Telescope, which is not since Apollo has NASA had a bigger flagship mission, which will be launching in the next year on an Ariane 5 from French Guiana. That is a cooperative completely cooperative activity with the European Space Agency. In fact, the European Space Agency is providing that Ariane 5 for NASA to put the James Webb Space Telescope on. Just a week ago, the head of science for the agency, ultimately my boss, Dr. Thomas Zerbukin, was in fact in French Guyana. Many of you might have seen his tweets or agency tweets, if any of you are followers of that. Have seen him. He was actually in French Guyana looking at a launch that happened last week of the latest Ariane 5 and was very much impressed by the Ariane 5 team that's down there. So that cooperation continues, and it is really robust, and it has not slowed down any of our activities. And in this case, on a very high level, in terms of agency flagship missions, James Webb is on a really good trajectory for being delivered and put on orbit. So that's exciting.
That's wonderful. Glad to hear about that. And Pete, time flies when you're having fun. Wish we had wish we had more time. You'll have to come back.
Well, I'd be happy to, and I really would. And so don't hesitate to ask. And I'm very honored to have been asked. And I'm a huge proponent of what the foundation is doing, and there's a lot of work to be done there. And the accolades that I heard early on, kudos to the entire foundation team, because it's hard work. It really is hard work, and it's meaningful. It really is very meaningful.
Thank you so much. If you'd like to support that effort that Pete is talking about, you can go to www.f4f, that's the number 4, .space. Thank you so much. Let's see. Laura Forzik and What's Going On are our next event. Ms. Forzik is the owner of space consulting firm Astralytical, specializing in space, industry, and policy, and offering space career coaching services. She is a NASA subject matter expert for planetary science missions and is also the author of Astralytical Explore Flybys and Orbits Analyticals, which I highly recommend. Ms. Forzik is also the author of the book Rise of the Space Age Millennials and is a frequent source for news publications, regional newspapers, and public radio. We've seen a lot of her on the news lately, and it's really an honor to have her here. Great to have you back, Laura. What's going on?
Hi, Lee. Thanks for having me back again. And you're seeing me a lot on the news because there's a lot of news going on. I love it. I love how active our industry is. So this topic of this month's event is quite broad, workforce and industry based. So I'm going to narrow it down to one specific topic and then get to some other ones if we have time. But I want to talk about why certain components are so important and why jobs seem to rule. I'm going to talk about a little bit about space policy, why jobs seem to rule the day, numbers of jobs, the economy, all that gets the attention of a lot of people. And so I want to talk about NASA's Artemis program, specifically the human landing system. You've seen it in the news a lot since April, when NASA surprised everyone with the selection of only one Artemis lander for its Artemis 3 mission is SpaceX, right? So we anticipated 2 selections. NASA was saying they wanted to choose 2. But in that source selection document that NASA's Kathy leaders put out, they pretty much spell out, yeah, we wanted to pick SpaceX and Blue Origin, but we didn't have enough money. So we only offered it to SpaceX. And that caused an uproar, especially in certain political circles in the Senate and in the House. And a lot of attention has been brought to this since then. Very recently, the Government Accountability Office, the GAO, published their finding that this selection was done properly. So the losing competitors, which was Blue Origin, National Team, and Dynetics, they protested this. They said, you know, NASA changed it. They were going to select 2. NASA incorrectly select SpaceX. You know, they had a lot of arguments. And the GAO said, no, this was fine. NASA did things properly. And so what you know is Blue Origin come out with a series of public and probably behind the scenes initiatives to try to get more funding for NASA Artemis HLS so that Blue Origin can get a contract. That's their goal, right? And why am I bringing this up in the context of today's talk? Because I want to talk about jobs. So you might have seen NASA over the decades talk about how many jobs it brings to the US economy, how many states are involved. NASA has, depending on how you want to count it, 8 to some teen number of facilities around the country that employ X number of jobs directly through civil servants. And I don't even know how many contractors and subcontractors. That's a big playing point for NASA because NASA is a political agency. It is bipartisan or nonpartisan, but it gets its money from the government. And so it needs to say to every member of the US government, every elected representative, every senator, everybody that it can reach, that NASA touches you and your community, and this is why you should fund NASA. So taking cues from that book, Blue Origin and the national team have also decided to take that approach. Now, what is the national team? The national team is Lockheed Martin, Northrop Grumman, and Draper, along with Blue Origin leading the team. And they've taken that same approach where they have touted over 3,000 jobs in the HLS program with the national team, over what they say, $618 million with small businesses. And I don't even know how they count that. And they are working with 200 companies across 47 states. So they're playing the political game. And this is really an interesting contrast to the winner of the HLS award back in April, that SpaceX is well known for not working with many companies at all. SpaceX very much is siloed. They are self-sufficient. We had very rare news that they have acquired a company. I don't know if they've ever acquired a company before. If they do, I'm not aware of it, but they just announced, or I don't even think they announced it. Somebody found it, that they acquired Swarm Technologies, which is extremely rare because SpaceX tends to get its technology through other means, like acquiring employees, for example. And so it's very rare that SpaceX works with any other company. But you've got this other approach of working with all the companies. And the other competitor in HLS, which is Dynetics, also had that same approach where they list 25 companies and universities that they're working with. And I closed the tab. I wish I hadn't closed it, but I was going to read to you some of those names. It's a lot of companies and some big names too. Draper was on there again, Sierra Nevada Corporation. I mean, I can't remember off the top of my head, but same approach. We're working with all these companies around the country, which is why you should give us money, because we're providing jobs. And what Blue Origin is doing now is they're taking this big political initiative where Jeff Bezos is saying, if you give us this contract, this HLS contract, then we will waive the payments for the next essentially 3 fiscal years, the current fiscal year and the next 2 fiscal years, up to $2 billion. So it's really Blue Origin saying that we're going to pay the shortfall, quote unquote, of NASA not having enough money for the HLS program. And this is important because it tells NASA, and more specifically, it tells Congress. So this letter, this open letter that Jeff Bezos wrote, it was directed to NASA. It was directed to NASA's Bill Nelson, the NASA administrator, but it was really written for Congress. It tells Congress that Blue Origin is willing to provide private equity, or not private capital, private wealth, Jeff Bezos' own private wealth, to providing jobs, providing these 3,000 jobs, assuming that Blue Origin continues to work with the national team companies, providing all these work with small businesses, et cetera, et cetera. And so it's really a way for Jeff Bezos to say, hey, we're going to do this, and we want to get that NASA contract, right? And remember that NASA also wants this. So back in that April decision, NASA's like, yeah, we wanted to select Blue Origin, but we didn't have enough money. And NASA is currently working on another solicitation where they want to provide a tiny bit of money for the next wave of development. I think it's like $45 million, so not much at all, compared to about, I think it was around $2 billion that NASA awarded SpaceX, because this is really expensive. This is not just sending a payload to the surface of the moon. This is sending human beings to the surface of the moon. It's not just landing. It's also the descent and the ascent, and it's a whole complicated thing with merging with the SLS and Orion. So it's actually quite complex. And so $45 million isn't really going to get too far, but playing that political game will probably get Jeff Bezos what he wants, which is a Blue Origin award. We don't know that for certain, and it might not work out the way he said in that open letter, for example, of awarding another contract during that next step to Appendix H. But next step to Appendix N is the next step. And I'm not going to get into the contracting, but basically there's the next stage of, after Artemis 3. Artemis 3 is just the first one. What's going to come after Artemis 3, Artemis 4, Artemis 5? The plan is to continue it for forever, as long as the government keeps funding it. But the important part is,
interrupt?
Sorry?
Can I interrupt and ask a quick question?
Yeah.
So what are the laws? Is it considered a bribe in a way to say we'll pay part of it? How does that work?
Yeah, I'm not a lawyer, but from what I've read, that this is sort of a gray area that is considered legal. A grease payment, is that the term? I'm not a lawyer, but basically, yeah, it is legal to say we're going to do this. And in fact, you can say that SpaceX has already sort of done that without saying it, right? SpaceX has this plan, Elon Musk has this plan of sending humans to Mars, and humans to the moon can help him develop that technology. His Starship rocket, the way that you land on a planetary surface, etc. And so SpaceX, Elon Musk is already putting in a lot of money, their own money, into developing Starship. So in a way, that's what Jeff Bezos is saying that he's going to do, and probably should have done from the start. But I'm not a lawyer again, so I can't speak to the legalities of changing contracts or offering to pay. I just don't know how that works too well. But my guess is that since Congress wants this, NASA wants this, and Blue Origin wants this, they're going to figure out a way to legally do this. And whether or not it works out exactly as laid out in that open letter that Jeff Bezos wrote to Bill Nelson, I don't know. I was about to make a point about something different from Apollo. Yes. So I did want to emphasize that this is different from Apollo because NASA is not just owning this hardware. And this was a debate in the previous Congress, especially in the House of Representatives, of maybe NASA needs to own this hardware. Maybe NASA should own the lander, just like we did with Apollo. But that seems to have lost out, that philosophy, because we're seeing NASA contract out services, just like it's contracting services to the Commercial Crew Program, which I'm going to talk about in a little bit later, contracting services to, the other kinds of the commercial lunar payload services for Artemis, the CLIPS program. So it's a really different way of thinking. So the idea is that these companies, SpaceX, maybe Blue Origin, maybe Dynetics, is going to develop its own technology that they can sell to others, not just NASA, but it can then use this technology, this landing system, to sell to other government agencies, other governments, private individuals with lunar tourism eventually. So I don't want to spend too much longer on that because I do want to get to start some other things, but yeah, so that's an area of jobs. Like when we think about NASA, we want to think about it as an innovative government program, government agency that really derives the technology, but it's also a government program. And some companies have different philosophies, whether they consider themselves to be lean and innovative, or whether they consider themselves to be a jobs program that they can then tell Congress that, yeah, they're providing jobs to 47 states across the nation, et cetera. So it's just a different philosophy. Components. So I want to talk about how launch companies are also wanting to get into components. And this is not necessarily something new, but it's something that we're seeing expand. So for example, Relativity was mentioned in the previous talk. At the end of previous talk, it's a 3D printing company that is developing its own launch system, but it's also developing rockets and other components that it then can sell. It can either sell the services of its 3D printers or the rockets themselves. And there's other companies that want to do this. Firefly just announced that they're trying to do that too. Not 3D print exactly, but sell rockets. So Firefly does have a small launcher that it wants to launch very soon, but it also is planning to now sell its own rockets and its components. And Blue Origin has also taken this approach where Blue Origin has a New Shepard suborbital rocket, and it has its New Glenn that it's working on. And while it's developing this engine for New Glenn, the BE-4, it's also sold that engine to United Launch Alliance. And you might have seen this in the news recently because the BE-4 is quite delayed, which, you know, everything aerospace is delayed, but that's a problem to the company that's bought those engines, which is United Launch Alliance. So United Launch Alliance by law is no longer allowed to buy Russian engines for its Atlas 5, and that's why it's retired the Atlas 5, because it's now developing Vulcan, which is going to use this American-made engine from Blue Origin, the BE-4, and there's a bit of a delay there. And so when you're thinking about components, it's not just, you know, it's not just the technology. There's politics involved, and it's geopolitics. It's, okay, do we buy from the Russians? And this was a decision that was made several years ago when they invaded Crimea, I think. I don't remember it anymore, actually. But yeah, there was a lot of politics, and they were like, no more Russian engines after 2022, maybe. I don't remember exactly. But, you know, there's geopolitics involved. It's not just the technology. Also want to talk about how components can really kill some major programs, or not kill it, but really cause some problems, cause some delays. So I want to talk about how, for example, Rocket Lab just launched again. They had their third failure, their second failure in a year. I mean, Rocket Lab's doing great, but they do have these failures that keep popping up. And the one that they just fixed, and went and did a return to flight just a couple of weeks ago, that was due to an ignition system. So just something as small as how to ignite your rocket can cause problems. Thrusters can cause major problems and almost destroy the International Space Station. So we saw a big problem with the Russian module, and I don't know how exactly to say that, but Nauka, I don't know, I'm sorry. But in any case, that a module docked to the International Space Station. Everyone thought it was fine, and then it started throwing its thrusters, and so thrusters almost destroyed the International Space Station. I mean, NASA really downplayed it, but it's coming out now how serious that actually was. You know, there was no structural damage as far as we know, and everything seems to be fine now. But imagine if things had gone just a little bit differently and they had something break off the International Space Station, or something structurally was damaged and they had to evacuate space station. I mean, things like that, just a component, just a thruster could really mess up an entire facility in space. And that's how delicate these facilities are. So when we think about the future, we need to think about how each component can really affect all the other components, all the other systems involved. Also want to talk about how we have right now an investigation going on into Boeing's Starliner capsule and the valves that are just not closing. These valves are for the thruster system, and there's 13 of them, and they're not closing properly or opening properly. And that's another component that's been delayed, that's delaying this program that's been delayed for so long. So if you remember back when the Commercial Crew Program was first awarded to Boeing and SpaceX, they were supposed to launch in 2017. So both SpaceX and Boeing were quite delayed. SpaceX launched their Crew Dragon in May 2020, and now they're launching pretty regularly. But Boeing, unfortunately, has had worse luck, where they had an uncrewed test in December 2019 that just went terribly with that problem of the software having the wrong timing. And so they fixed that, right? But now they're having all these other problems. And yes, there's some delays that weren't their fault, like that Russian module messing up the attitude of the space station. But now they're really delayed because of valves. So little components can really mess up things. And I don't have a lot of time left, so I want to leave time for questions, but I do want to mention some six jobs and the future of commercial space. So I've mentioned a lot of space policy. I've mentioned a lot of government programs in this talk. I want to talk about how it's not all government, right? We're now entering an era where commercial space companies are acting on their own and making money on their own, and not necessarily in partnership with government, although sometimes they still want government funding. And I'm talking about the suborbital launches that we saw in the news quite a bit lately with Virgin Galactic and Blue Origin. And this isn't new in the sense that these two companies have been launching suborbitally for a few years now, but these were some particularly high profile launches, with Blue Origin launching their first paying customer. That was the 18-year-old Oliver Damon, who paid an undisclosed amount of millions of dollars to fly. And there were no government programs, no government people on that flight. And then Virgin Galactic, who also flew its own people, but flew a science project, a plant biology experiment for the University of Florida. And University of Florida technically probably got government money to then have that project run, right? Still, it wasn't a government project. It wasn't NASA. NASA has booked flights on projects on these missions through NASA Flight Opportunities Program. For years now, they've been doing that. So flying science on these missions, on these flights. But the big moneymaker is probably in the near term going to be the backlog of space tourism that we're seeing, where Virgin Galactic has sold over 600 tickets and just opened up their ticket sales again at a significantly higher price. It used to be 200,000, then they raised it to 250,000, and now it's raised again to 450,000 per ticket unless you're a research mission, in which case it's 600,000. And there's some other details in there. Blue Origin has not announced their ticket price, but they have sold. Last time they announced this, they sold about $100 million of tickets, and that was a few weeks ago. So they're behind the scenes selling to wealthy people. And so this is nothing to do with a government program. This is commercial companies making commercial, doing commerce in the private sector, which has been really looked down upon in the news. But I think it's kind of exciting to see that we're not so reliant on government anymore. And I'm going to stop here and open it up to questions. Yes, I apologize for my son. He is in the background.
You have bulletproof concentration. I'm not
Practice.
sure when mine were that age that I would have been able to continue with a sentence without interruption. So great job. And we've enjoyed hearing his little voice along with yours. You've talked about components and then government, non-government. There's kind of another aspect that is in the news lately where it's space and not space. So Leo Labs is a company that actually operates on the ground to monitor space debris. And I think they just got $100 million in funding to put things around the Earth on the ground to monitor and better create an environment where we can do something about space debris. Can you talk a little bit about that deal? Is that something that you're following?
Leo Labs is a fantastic company. Whenever you hear about some conjunction possibility, it's Leo Labs likely that has put out that information, along with AGI and a few others that are tracking it and doing a fantastic job tracking this debris and material satellites that's up there. And so it's a difference. I don't call it space and not space. I call it space assets and space data. Space data is a huge segment of the economy. It might even be the biggest segment of the economy. I'm not entirely sure off the top of my head, but when it comes to things like communications and broadcasting and data, Earth observation data, satellite internet through Starlink and OneWeb, etc., cloud services. I mean, all of that, it probably is the biggest segment of the economy when you're talking about space data as a whole, because that has the most, the widest applications for all industries, right? So if you're talking about sending humans up into a space station and to the moon and Mars, that's a very limited segment of the population. That's government and a little bit of tourism or private research. Data to industries on the ground that maybe you don't even realize. There used to be the I am sorry. Can you hear me now?
Yes, yes, I thought that was me.
No,
Are
no,
you?
it's me. In any case, I don't know where you left off, but yeah. So that is probably the biggest area of growth is using space data, just simply because of the wide variety of industries that can expand into using space data in some way or another. And that could be launching their own satellites for their specific purposes, or using the satellites that are already up there, or ground stations, and tracking and all of that. So yeah, big area of growth.
Thank you. Let's see. I want to shift gears a little bit and go in a slightly different direction. Did you see the closing ceremony of the Olympics?
No, I missed it. What did I miss?
Well, they have the closing ceremonies in Tokyo, and then they do a feature on the upcoming games in Paris. And they did a long rendition of La Marseillaise, where they had symphony in the symphony hall, and then in the opera house, I assume. And then they had individual instrumentalists around the city of Paris in famous locations highlighted. And then at the very end of the song, they had a French astronaut on the ISS play just the refrain on his saxophone. And
I saw that picture. Yes. I
it was
love that.
it was
I don't
beautiful.
know if you have a question in there, but one thing I want to highlight with what you just mentioned is the fact that we're all humans, right? And there's a lot of criticism, and some of it well deserved, that we're just spending money in space that could be used on Earth, but we're people, right? And even all the money spent in space is spent here on Earth, but even when we send up people, they're still humans, and they've got that ability to touch the people on Earth, whether it's during the Olympics, or whether it's, the Inspiration 4 crew having their picture on Time magazine today, or all these opportunities to inspire. Wally Funk, after 60 years of trying to become an astronaut, finally getting to space. I mean, so many different ways to inspire people. And I don't know if you had a real question in there, but I actually absolutely love these images of the people in space being human beings, being fully human, and really showing the world that you don't have to be some untouchable astronaut. You too can relate to the people up there, because you might be in some future a person who gets to fly in space someday.
Yes, it's a good point. So I guess my question on that is, it reminds me of your description somewhere that I read of wanting to dance on the moon. What dance would that be? And would you be alone or with others?
Oh, I'm so glad you mentioned this in the context of the Olympics, because there were 4 videos that were put out maybe 2 days ago, over the weekend, I think, that showed the astronauts on the space station doing Olympics moves. And 2 of them, one was like synchronized swimming, and one was gymnastics, I think. And they looked sort of like dance routines. And I'm thinking, what amazing dance routines can you put together in microgravity if you had the time and the skill and the experience to know how to put together a dance routine? I know there's some people on the ground who are actually studying this, but same with on a surface of the moon that is 1/8 the gravity of Earth, right? Did I get that right, or is that Mars?
1/6. Yeah.
I mixed them up right now, but it's a real opening of the possibilities of what you can do in space, in terms of art, in terms of sports, in terms of the it's not just science, but science is involved, because science can help dictate your art, help you define your art. And so I absolutely love the idea of imagining what a future could be for, I'm a scientist, so I'm biased, right? But beyond the science of the art and the entertainment and the sports, and that's coming, right? We've got the Russians that are trying to fly a mission by the end of the year to fly actors and a film producer to the International Space Station. So this kind of thing is coming. And what are we going to imagine? What are we humans going to imagine for a future where this is a real true possibility of flying artists and the Dear Moon project around the moon, these kinds of things. And I think it's really important because it connects to people on Earth. It's a real way to say, we are humans and we're just like you. And you too can be involved in, expanding humanity beyond our home planet.
Thank you for bringing up those videos. I did see them, the two synchronized swimming videos, and I was surprised with Russia's very proud history of ballet and gymnastics and synchronized swimming and rhythmic gymnastics. They're just stellar plays over the decades in those fields. I was surprised that the Russians, I would have, they would have been out of medal contention for me.
Yeah, I thought they all did a fantastic job, given how difficult it is to work in microgravity and to move your body. So I've done the parabolic flights through Zero G Corporation and through NASA's Ellington Field, and it's hard. You're a bouncing ball, bouncing around in that fuselage until you get used to it. So my hat's off to them because I thought they all did a great job.
Great. Well, we will be hearing a little bit more about Ninja Warrior on the moon and about a video shot in a parabolic plane today and tomorrow in Saturday Space Segments. Laura, it's always a great pleasure to have you with us. Thank you so much.
Thank you.
Our next speaker is Kai Statz. He's an entrepreneur, filmmaker, and researcher whose work includes Linux operating system development, data processing at LIGO, and the construction of East Africa's first research-grade astronomical observatory. His team of professional researchers, aerospace engineers, and volunteers are now constructing the world's highest fidelity Mars habitat analog at the iconic University of Arizona Biosphere 2 in southeastern Arizona. Kai, the screen is yours.
Hi, thank you. Welcome. And I should say thank you for welcoming me, and it's an honor to be here. I've been following this forum and the foundation for quite some time, and was pleased to be asked relatively recently to be a part of this. So thank you. I'm going to go ahead. I'm going to turn off my video just to make certain I have proper streaming bandwidth, and then turn on my screen here. Okay. Can you see my screen?
We can see that just fine.
Okay, great. Let me hide the controls just a moment. Okay, good. And here we go. So thank you again. As mentioned, my name is Kai, and I'm a researcher at the University of Arizona, and specifically at the Biosphere 2 campus. Hopefully most of you have heard of the Biosphere 2. It's an iconic landmark and an incredible engineering endeavor that in the mid 90s or early 90s was really one of the world's first and definitely one of the highest fidelity analogs for what someday might be the means by which we live on another celestial body. So I'm going to tell you a little bit about how our team has, over the course of the last just 6 months, really, following a couple of years of development and fundraising, taken a portion of the original Biosphere 2, and we're now converting it into a high fidelity Mars analog. And I'm going to, some of this presentation is standard for how I present SAM, but I've integrated it to the best of my ability to the Foundation for the Future and the workforce development. So towards the end of the presentation, I'll go into more of the details of how what we're doing really is about education as much, if not more, than preparing us for actually living on other celestial bodies. Oops, there we go. So we're talking about analogs. So an analog, the best analogy I like to say is that swimming in a swimming pool is an analog for swimming in the ocean. You want to start in relatively safe environments before, I'll let somebody else admit that person. You want to start in safe environments before you go into perhaps what could be known as the more dangerous environments. So a number of analogs. One of the first ones really, at least in the United States, was at Meteor Crater, Arizona, in the upper left-hand corner here. And Gene Shoemaker, who was a planetary, or really the father of planetary geology at the University of Arizona, used Meteor Crater as a means to train the Apollo astronauts back in the 60s. And then in the right-hand corner, we have the Neutral Buoyancy Lab, where astronauts train to be on the space station, fully immersed in the best simulation we can do on Earth of microgravity, which is in a water environment. In the center, we have high seas in Hawaii. We've got Hera and Lunar Palace 1, the bottom center, and of course the Mars Desert Research Station. And this is just a few of the many analogs that are available. So if you look at the wide variety of analogs that are operating today, there's really a growing number. In fact, just yesterday, we received news that NASA is building a 3D printed analog at Johnson Space Center. And there's one in Brazil, there's one in Hawaii, in Poland, in Utah, a couple in Texas operating by NASA. There's Sirius in Russia, which is funded by NASA. Each one of these analogs gives us something different, a different kind of experience for analog astronauts, and you take away a different set of skills and a different set of perhaps experimental endeavors. So analog astronauts, what does that mean? It's a relatively recent term, but the concept has been around for a long time. As in the previous presentation, we talked a lot about how the everyday person, maybe the average citizen, may have a chance to be involved in human space exploration directly or indirectly. And an analog astronaut is really an opportunity for researchers, for citizen scientists to experience some of the challenges of being in these confined environments that will be the spaces in which we inhabit when we're on the moon or Mars or in transit between them. And the research, at least to date in the last 22 years, with a lot of experience coming out of Mars Desert Research Station, is in psychology, food studies, geology, microbiology, human-machine interfaces, haptics, life support systems, plant physiology, and food cultivar production, et cetera. And really the plant physiology, food cultivar, and life support systems can be combined into what's known as bioregeneration. So we're testing new technologies before being deployed in space, and we're training for and testing new procedures in these relatively safe environments. And so I want to come back to the biosphere. This is just a beautiful shot, and this is a relatively recent shot. That's what it looks like today, with the Catalina Mountains and Mount Lemmon in the background, just after a nice winter storm. And this was a 3.5 acre sealed building that, when operational from 91 to 93, and again for a shorter stint in 94, had less of a leak rate, not by percentage, but by volume, by actual amount of air, than the space station does today. It was an engineering marvel, absolutely incredible endeavor. That gave us a lot of rich history and a rich research, I should say, 20 years of research. Even today, as an open ecological research center, there's a lot of information, a lot of data coming out of the research that continues to be operated here under the University of Arizona's guidance. So there's a full ocean. Again, for those of you who have not been there, there's an ocean, which, if I understand correctly, is the longest running saltwater research ocean and one of the larger ones in the world. Goes down 24 feet, has a coral reef that we're currently rebuilding, has a wave pool. There's a rainforest, which is absolutely magical. I love going in there at night, especially with all the roaches and the ants and all the nightlife that comes out, and a desert biome as well. So back in 1987, there was a thing called the test module. And the test module was built before Biosphere 2 was constructed. And this was a means by which the biospherians were able to test some of the concepts of this sealed, hermetically sealed habitat. They tested the space frame, which was inspired by Buckminster Fuller, a welded steel floor, and on the right-hand side, a lung, which provides the constant pressure regulation and kind of an internal positive pressure. We won't go into the engineering details of that, but that in and of itself is quite interesting. So I was here in Biosphere in 2019 doing a plant ecology research project for CMOC at Arizona State University. I'll talk about that later, and took a tour of the campus with then Deputy Director John Adams, and we walked past this building, which looked nothing like this. It had been overgrown by the desert, just weeds and plants and trees everywhere. And I said, John, what is this? What is this building? He says, oh, well, that's the old test module. I said, well, it looks like a spaceship. What are you doing with it? And he says, nothing. He says, if you can figure out what to do with it, it's yours. So 2.5 years later, This is what it looked like when we started. Some of all the original plumbing and wiring, and a 2,000-pound heat exchanger suspended from the ceiling, and the last of the dirt beds that were used in an early 2000s experiment. And this was our first day, January 20th, 2021. In the midst of COVID, we dove in and started working on it. So our goal was to transform this, refurbish it, and give it new purpose and new life as a fully hermetically sealed research facility for long-term human exploration of space. And so we've been grinding and cutting and vacuuming and rewiring, and we've had just an incredible effort. It was a very, very long, hard days for 6 months straight. And we were working on the space frame, working on the interior, applying new window tint, and that takes me into a slight just a side note, is that everything we're doing is done to the best of our ability with the application of a scientific principle. And so even the application of the window tint is designed specifically to reduce the optical transmission of light by 50%, so that when you're inside, you're seeing light the way it would be on the way it would be on Mars. Just a moment, let me get rid of this. And we're also working with Pacific Spaceflight. And Pacific Spaceflight and Smith Aerospace Garments is an organization out of Portland, Oregon. And so we have we've purchased, and they are complete, 2 fully pressurized spacesuits, so that analog astronauts who enter in our facility will be able to explore the adjacent half-acre Mars yard using a fully pressurized spacesuit. And this was a prototype, an earlier prototype that we brought out just this spring. And Deputy Director John Adams actually donned this spacesuit and walked around for 1 hour, breathing entirely through the umbilical cord, which was provided from compressor on the inside of the module. And he has a lot to say about that experience and how much that really taught him what it feels like to be in this suit. This suit was pressurized this time to about 1.5 psi over ambient, but it's capable of 4 psi, which takes us up 4.7, takes us up to the what would be the pressure of a suit on a spacewalk, for instance. And we have our first shipping container arrived. There'll be 3 of those total. That'll be the crew quarters added in addition to the greenhouse structure. We've put in new air conditioning systems, and we've repressurized the module. And again, that's an engineering endeavor that's just a beautiful way of maintaining constant positive internal pressure. And most of all, what's been really fun about this project is the volunteers. We've had volunteers coming from all over the United States, even from Peru, and we've just had a lot of fun with about 7 or 8 people total over the course of that 6 months, and providing all their skills and their experience and their enthusiasm. And they've also taken away a lot from us as well through that experience. This was our closing crew, with Deputy Director John Adams on the right and myself in the middle. And I also always want to give kudos to my partner, Trent Tresh, who's right here. And Trent has been literally moved from Seattle to make this happen, and been living at the Biosphere 2 for the last year. So this is as we left it at the close of June. And just some of the key features that I'll leave with you, and then we'll move into more of the CMOC and then the workforce discussion. So again, built on the legacy and the experience of Biosphere 2, the staff, the university professors have been just outstanding in helping guide this endeavor. We have a 400 square foot controlled environment, meaning a greenhouse, 1,100 square foot living space that we're building starting again in September, and on-site mission control center that was just given to us, a 1,200 square foot building that'll be entirely dedicated to mission control. And we have a former SpaceX employee who's going to be helping us design that system. And teams selected, the teams can select whether they want regulated airflow or hermetic seal. We're going to be using airlocks and pressure suits. The Mars yard will have a scaled crater, a 6,400 square foot indoor crater sculpted by a company out of Tucson called Chemrock that has done, or Semrock, sorry, who has done zoos and aquariums all over the world. We'll have a synthetic lava tube and a gravity offset rig, so you can actually strap yourself into a harness and experience reduced gravitational fields, 1/6, 1/3. We're building a neutral buoyancy lab. We found an existing fish aquarium on site inside one of the old greenhouses, and it's large enough for 2 scuba divers and a person in the center with a spacesuit, and that'll be our prototype, and then we'll raise the funds to build a proper neutral buoyancy lab. And then, of course, moving into advanced computer models and simulation with CMOC. So the principal objectives, science objectives, are transition from physiochemical, meaning machine-based, to bioregeneration life support systems. So everything on the space station, everything on the space shuttle, and all prior missions has always been physiochemical, meaning we're using machines and chemicals to remove the carbon dioxide, to replenish the oxygen, if we're not bringing up bottles, and also to clean the water. We're going to be transitioning from that physiochemical into bioregeneration. That's never been done before, as a demonstration of what will happen when we're actually on the moon or Mars, and transitioning from 2-week or 1-month stays into multi-year stays. We know that we're always going to have kind of a mixture of machine-based and plant-based. But what happens when you transition from that machine-based system into the bioregeneration? Can we reduce the load on the physiochemical systems? And what does that look like when we plot, or when we study the air quality and such as we move through that process? So we're going to be transforming simulated regoliths to soil, including the removal of perchlorates. We're going to be studying the microbiome of the built environment, which is incredibly important. If you followed the space station, they often have challenges with biomats building up behind electronics and some of the areas where the moisture gets caught, working with pressurized suits, as I mentioned, and advanced computer models. So as I said before, we just finished our first test module restoration. I won't go through the rest of these in detail, but we do dive in again in September to the construction of the crew quarters, and we are hoping to have our first teams arrive in mid to late Q1 2022 if everything goes well. So just an artist rendering, an older rendering actually, an artist rendering of how this will appear when we're finished, and the interior of the test module, and an early layout of what might be the crew quarters or the living space. And that'll include toilets and sleeping bunks and a common space, kitchen, workshop, also a place for repairing things and building things, including a 3D printer, and of course our airlock. And this is an existing, just a moment. There we go. This is an existing greenhouse structure that we're retaining. Inside that is where the scaled Mars crater will be built. So in June, the last couple of days of June, we conducted the first sealed test of the test module in 30 years. And this was exciting. It was really fun. This is what we've been working for 6 months. So we had a few plants growing. We brought in from the University of Arizona, SEAC, which is an advanced agricultural research center. We brought in an entire plant study, and we played a board game. We ate NASA-approved Doritos, and we put together a robotic plant watering system during the 4 hours that we had 5 people inside. And as we were hermetically sealed, we were monitoring CO2, oxygen, pressure, humidity, and temperature, and using LabQuest systems from Vernier, which is really an outstanding product line, especially for academic studies. And we did, to the best of our ability, we did baselines for CO2 and all of the items I just mentioned, and then conducted our data acquisition and tests to demonstrate when the door was sealed, when we increased the pressure inside by inflating the lung, and also when we turned on the CO2 scrubber. And all of this, the full analysis of this is available on our website. So briefly, I'm going to mention CMOC. CMOC is often its own hour-long presentation with the interactive demonstration and such. My team developed CMOC at Arizona State University in the School of Earth and Space Exploration under the Interplanetary Initiative from 2017 and 2019. CMOC is currently hosted by National Geographic and is available to the world. So any of you who are classroom instructors, virtual instructors, or are just interested citizen scientists, I encourage you to go to cmoc.space and give it a run. It's a lot of fun. It's a really amazing program. And we're continuing to develop with a professional development team. This is just the dashboard, but you as the user design your habitat. You choose the number of astronauts, solar panels, batteries, how large is your greenhouse, how large is your crew quarters, how many plants do you want, and all the data is from NASA. It's all NASA and Paragon Space Development Corporation, authentic data that's been validated, vetted, and including the plant growth model. So this, in essence, is the digital version of SAM, or you could say SAM is the real-world implementation of CMOC. And that gets me to something that I think is very important for developing skills for the real world and for developing the workforce of tomorrow, which is how I'm not a classroom instructor, so I can't say this with conviction, but in my experience and in what I've seen happening in the university is that, and in the world as a whole, is that we don't seem to have really strong critical thinking skills in some of the people coming in the next generations. And I think some of that has to do with a lack of hands-on experience with the scientific method. And so we believe and we feel that by identifying and employing authentic data and developing and validating a hypothesis, becoming fluent in the iterative scientific method, and we can improve those critical thinking skills for the next generation. And hopefully show people how exciting and how much fun scientific research is, and that this entire space arena, this new space arena, and really the second wave of the Apollo style programs is getting people excited about human space exploration again. And I think that hopefully will bring a lot of us back into engineering and science and technology, and show the adventures that happen both in the real world and in the data itself. And so CMOC is a way for people to connect with that. It's designed for grades 5 all the way through 14. And we have 2 different curricula that were developed following the next generation science standards. And so it's aligned with that. And again, hosted by National Geographic. So we're now in the process of integrating the two, of bringing SAM and CMOC together into a single entity. Ultimately, we want CMOC to actually run SAM. So we're going to be taking the data that comes out of SAM and pumping it into an artificial intelligence algorithm using reinforcement learning to improve the model and to train the model of CMOC, such that maybe a year or 2 from now, we can turn it around and actually use CMOC to operate the hermetically sealed environment. So my closing statement for this is that I love this statement, something we came up with as our team, is that we're engaging research teams from around the world in hands-on scientific discovery, and to inspire the next generation to be engaged custodians of this planet while we explore new worlds. And that really is important to me, is that, and I think the prior speaker mentioned this as well, is that people say, why are we going to Mars? Why are we going to the moon? We've got so many problems right here on Earth. We need to inspire people. We need to give them heroes that are beyond YouTube. And we also need, as we gain these technologies, these skills and these experiences to take us off of our home planet to explore beyond, we will inevitably, we're already gaining a better understanding of our own planet through the studies and the scientific processes and the technologies required to make that possible. So I really see CMOC and SAM as a dual system. Yes, we're helping prepare for our species to become interplanetary, but we're also becoming better custodians of where we live now, with better improved understandings of our processes, our impact on this planet, and how we can make the future better. So thank you.
Kai, that was fantastic. You're the definition of a polymath. If people have a chance to look you up on the internet, you've done lots of different kinds of things. Tell me about your decision to focus on this project before it was real.
It's a good question. I don't think these things ever happen as decisions, at least not in my life. It's not like somebody says, here, you should do this, and you say yes or no. These are things that just unfold gradually. And it's only when you look backwards, you see the connecting path. And it's not linear. It's a nonlinear. I live a nonlinear function. I think a lot of people, the more I explore this arena, I'm not the only one with that story, that we're living in a nonlinear world, and you have to be comfortable with that. You have to be comfortable just opening doors, looking behind the door, and seeing if you want to go through it, at least taking a look, at least sticking one foot in to see what happens. But not to say there's an incredible amount of effort. I spent 2.5 years developing, plans and proposals. I wrote 13 proposals in 2020 alone, only one of which was funded. And all of you out there in academia know what that's about. So I think for me, it goes back to probably a childhood dream of wanting to be an astronaut, but I'm of that generation that was kind of caught between the Apollo era and what we thought was going to be by the year 2020, we'd be, or by the year 2000, we thought we'd be living on orbit and in vast underwater cities. And that didn't happen as quickly as we had thought. So I think part of it's my childhood dream of wanting to be involved in human space exploration. And part of it really is that I have personally experienced a lot of isolation in a different way than COVID. I spent a lot of time backpacking, solo backpacking, living on isolated places. I went 6 weeks without ever seeing another human being on an isolated ranch in Colorado. And for me, that's where I grew the most. That's where I learned the most about myself. And so again, these habitats, these sealed habitats, whether it's MDRS or high seas or any of them, or in SAM, I believe that the people who come into these environments and choose to spend time there, yes, they're going to walk away with real world astronaut experience, or at least habitat experience, but they're also going to walk away learning a lot about themselves and about how they interact with their environment. And the best way to acknowledge that is to say that when you're in a hermetically sealed environment where every breath you take has to be mitigated, or you see the CO2 rise every minute, there is no buffer. We don't have the whole planet as a buffer. You've got a few hundred thousand, tens of thousands of cubic feet. When you take a breath and you breathe out, something has to manage that CO2.
Yeah.
And you will walk away with a very, very strong understanding of how much your body influences the space around you and how much you rely upon those mechanical and biological systems to keep you alive. And I think that's imperative. I think that's really exciting.
Yeah, I think it reminds me of my transition from public companies to a private company, where you feel every dollar you spend, you think about it,
Yeah.
right? And I hope that our space companies are thinking that way.
Yeah.
Um, we hear a little bit about some people who are making the rounds, trying to join all 13, get a patch from all 13 analog sites. They're like collectors.
Right.
Do you see that as beneficial to the research or as a drawback, or a little bit of both?
Oh, I hadn't really thought of it as being beneficial or drawback. No, I think it's fun. It's exciting. I mean, if people have the money and they have the time to do it, I think that's outstanding. I think as long as people are taking away, it's kind of like I happen to be in Colorado now visiting Cislunar Industries. I think Gary Kellman
Yeah.
has spoken here a couple of times. So I'm a co-founder of that company. So in Colorado, we had the 50, the 50 14er peaks, and people bag the peaks. They try to climb all the peaks. Okay, so you can say, well, is that a benefit or a detriment? I think as long as they're enjoying it, as long as they're not hurting anything in the way, then why not? But I'd also like to think that each peak and each analog can be memorable. And as long as people are taking away something unique from each one of those experiences, then I think it's outstanding.
Great. Laura, before you, talked about the importance of components. So you've been rebuilding this thing that was built in the 80s, maybe the late 70s even. You've got bolts coming loose. You may have to replace rusty pieces. How has that process been? How have you identified your supply chain? And just talk a little bit about that.
No, it's a good question. Thank you. It's a good question because sometimes I wake up in the mornings and think, wow, I'm building what might be one of the highest fidelity spaceships. It just doesn't have rockets, right? If it had rockets, we could fly. And at the other time I wake up in the morning, I think, oh, I'm remodeling another house. I promised myself I'd never remodel another house. I grew up with parents who always bought 100-year-old houses and remodeled them. So the skills and the application of the tools is what I've been doing since I was 8 years old, drills and sanders and grinders and paint. But the difference, to your point, the difference is that we're trying to apply a scientific process to this. So when we choose our paints, low VOC paints, which turn out to be horrible paints, by the way. Now I know why people use like high VOC paints because they actually work. When we choose, for instance, the window tint, or when we applied a silicone membrane over the top of the test module, we wanted to the best of our ability, simulate the fact that you'd never build a greenhouse like that on Mars. We know that, but we're starting with an existing structure. And so we're reducing the light that comes in, the direct light from above, by applying that silicone seal. So it's the supply chain, Ace Hardware, Home Depot, a few things from on McMaster and Granger's. So it's nothing too fancy at this point, but I'm not certain that that's all that different than a lot of the spaceships, the spacecraft that are built. You can't make every bolt yourself. You do have to, at some point, just buy off the shelf systems. And the more you can do that, the cheaper the cost. So it's taught us a lot about what we can do with existing hardware. And yes, sometimes we have to manually modify things, go to a local machine shop, have things made.
Yeah, yeah. Now, you talked a little bit about workforce and about some of the skills gaps, and they're not narrow skills, right? There seems to be fact-based, I can look things up, but it's that critical thinking. Will the program that you talked about make any effort or have any funding to try to measure the outcomes or follow the results of your efforts to share the scientific method with a broader audience?
Absolutely. So to start, when we accept the team proposals, those proposals must be based on scientific valor, right? So there's got to be, and it doesn't mean you have to have a PhD in your crew. It doesn't mean that you have to have necessarily published, but we want to make certain that the teams that are coming in recognize the value of building a proper hypothesis, and will help guide that if they don't have that expertise. Make certain they understand how to run a scientific process from beginning to end, collect the data properly, and prepare for publication. So we anticipate, we can't demand, of course, but we anticipate and will motivate every team to go through that process and to publish in some kind of peer-reviewed journal to the best of their ability. Of course, it doesn't always happen that way, but that's what we'll encourage. In terms of the skills, the skills that we're using now to build this are very different than the skills that we employed when people are actually living and working there. I think those are different skills. So a lot of that comes down to, as NASA knows through 20 years of psychological studies, it's difficult to live with that many people, with 1, 2, or 3 other people in a very confined space. I think COVID has taught us that, to a high degree. So I think some of the skills people are going to come away with, we would call soft skills, but they're very important people skills.
That's great. And one final question. Do you plan to make a film about this process, and are you currently collecting footage?
Yes, we are. We are collecting footage. I am a professional filmmaker. I spent 6 years shooting films for the National Science Foundation, and it's every day I think I should be filming this. I should be filming this, but no, I need to actually drill this hole. I don't have time to go get my camera. And so we are taking short pieces of footage as we go, enough that we could assemble kind of how this was built when we're done. But I would encourage everyone to go to SAM. Here, I'll just type it out real quick, samb2.space. Oops, that's dot space, not tapping. And go there. We have a running blog, and the blog is deep stories. I love long form storytelling. So we have over 1,000 photographs and really fun essays written by myself and the volunteers. So every step of the way, at least 2 entries per week for the last 6 months are captured there. And it tells the complete story, the trials, the tribulations, the challenges, everything we've been through. And most people really enjoy it. It's more fun, I think, than Twitter, and some of the short form storytelling. So I encourage everyone to go there under the blog and read that.
I hope that's not a dying breed. Thank you for putting new material out in that format.
Sure.
Thank you so much for sharing some of your story with us. We really appreciate it.
Thank you. It was an honor. Thanks for having me.
All right. And now for something completely different. David Chevrant, a loyal listener and chat participant on Conversations for the Future, had the idea for this upcoming panel a few months ago. He wrangled several other people to form this group to discuss propellant depots in space. And I say several other people, but these guys are kind of a big deal. There's so much to talk about. There's so much talk going on about on-orbit servicing these days, and today we'll get to hear about the history of efforts to get these ideas off the ground, as well as where these leading experts think we are headed today and how fast. I'll introduce all the panelists, and then I'll turn it over to Dallas Bienhoff, who will give the opening remarks and moderate the panel. David Chevrant is a pilot and mechanical engineer with over 40 years of multidisciplinary experience in aviation and space, business, and technology. He retired from NASA in 2013 and currently advises startups and mentors for space settlement design competitions. As an engineer with the Advanced Technology Development Office at NASA JSC, David proposed and analyzed several concepts for propellant depots, stage refueling, and lunar in situ resource utilization. David led a NASA SAIC risk analysis for a depot study by NASA headquarters in 2011, and after retiring, defined an integrated risk strategy for next-gen space, evolvable lunar architecture concept, to commercially supply propellant from lunar ice for NASA Mars missions. Thank you for being here, David. Edgar Zapata is recently semi-retired from NASA Kennedy Space Center after 32 years plus a little. His career spans the Space Shuttle program and many advanced programs in NASA and DoD. He is currently a member of the NIAC External Council and can be found blogging at zapatatalksnasa.com. If someone could put that in the chat, that would be great. Thank you for being here. George Sowers. Dr. George Sowers is a professor at the Colorado School of Mines, right down the street from my house, in the world's first and only graduate program in space resources. He has 30 years of experience in the space transportation field and has been thinking about propellant storage and distribution in space for many years. Thank you for being here, George. Dan Rasky. Dr. Dan Rasky is a NASA senior engineer and scientist and was co-founder of the Space Portal in 2005 and is the current chief of the Space Portal office. And finally, Dallas Bienhoff is the founder and space architect of Cislunar Space Development Company, LLC, a space transportation and logistics company defining a reusable cislunar transportation architecture for satellites, lunar cargo, and human lunar development missions. Now, I said that all very slowly because early on today we talked about trying to make space accessible and making sure that a smart regular person can follow along without too many acronyms. And so the reusable cislunar transportation architecture means moving things around between the Earth and the Moon. Dallas, thank you for being here and take it away.
Oh, you're welcome, Lee. Glad to be here. And first of all, happy anniversary to Foundation for the Future.
Thank you so much.
It's a wonderful series of events that you're putting on. So we appreciate that. And, you know, the panelists today, friends, colleagues, competitors, collaborators, we've all worked together, worked against each other in the past. Dan Rasky, a great supporter of New Space. So it's a pleasure to be a part of the panel and an honor to be asked to moderate. So I appreciate that. I will share a set of slides as we start. Let's see. There we go. And we should be seeing those now.
We can see your slides.
Excellent. And we should be, there we go. So propellant depots, for the uninitiated and the uninvolved, you know, propellant depots in space are really the gas stations of Earth. You know, we have gas stations on the corners of many streets. They're replenished by tanker trucks that come in and refill their underground tanks so that we, driving our cars or our pickups, can pull in, fill up our small tank and drive around for a week, 2 days, 300-400 miles and come back and refill again. And we want to take that concept into space. And so that's what in-space propellant depots are. They're a place to replenish and refuel space transportation vehicles so we don't have to throw them away, but we can refill them and reuse them. So I'm going to talk a little bit before getting the panelists involved, but we'll start with a stage refueling, which is a ULA approach, kind of a depot precursor, if you will. And I'll show some pictures of depots and more depots and more depots. This is not a new subject, by the way. It's been studied since the 1970s, and it was, I believe it was even part of von Braun's Mars mission story. Mention a little bit about the impact depots have, the types of depots there are that have been looked at. What are the functional capabilities? That is, what must a space propellant depot do in order to be usable? And where might they be? So stage refueling. This is a ULA concept, George Sowers' brainchild, I believe, but the Vulcan and the Centaur and the upper stage, they also called it distributed launch, where they would launch a heavy payload on a Vulcan or an Atlas V with a large upper tank, and then they would launch a second vehicle and take that upper stage and transfer propellant between the two so that they can move larger payloads out to GEO or onto the moon. So this is a precursor to what propellant depots are. But like I said, depots have been studied extensively since the 1970s. A lot of NASA studies, especially in early days before shuttle flew, about how we might use shuttle to help us move beyond low Earth orbit with a vehicle that just gets to low Earth orbit. So even more depots, including how to support the Orion with the Centaur, propellant depots in the 1980s that were really a destination for reusable transportation launch vehicle that was a propellant tanker to orbit. Propellant depots in the news from the Houston paper, the Chronicle, about putting up depots and using them to support extensions into space. And even more depots, some fictional, some the upper left-hand corner is a NASA concept for an in-space cryogenic propellant storage and transfer demonstration satellite. I was part of the Boeing study, led the Boeing study on how to implement that concept back in 2011, 2012. We provided a proposal to NASA, as did 4 other companies. NASA took it in-house, and it was reformulated as a continuing on-ground, in-ground or ground-based demonstrations, never to fly or not yet flown activity. The lower left and lower right are concepts that I developed while at Boeing to use refueling to extend the capability of Constellation, the precursor to Space Launch System. Orbit Fab in the lower middle, those are small CubeSat type tankers for CubeSat missions or small satellite missions, storable propellants. The upper middle one is a concept from Tweeterville, if you will, and then a science fiction one or Kerbal Space on the upper right. And even more depots, the ULA sunshade concept on the upper left. This is a passively cooled concept that is no refrigeration. So it uses boil off to manage the thermal properties. A concept in the lower middle. The one in the upper right is those are ice cubes around a central core. So storing ice as a means of storing propellant in space. And even more. John Strickland is an author and a National Space Society member, board of directors. And he's developed concepts that are really ULA tanks, the passively cooled ones, on a long structure. So sending up tanks and mounting them to a structure as a way of replenishing a depot in space. The SpaceX version of transferring propellant from vehicle to vehicle, avoiding a depot, or maybe even the vehicle becomes a depot before it refills a space-based transfer vehicle that goes to the moon or onto Mars. And depots are a way to uncouple the launch of propellant from the launch of hardware, so that the propellant launch is not in the critical path of the mission. That is, the mission does not rely on propellant getting there before it is launched. And then got to be parochial in the CSDC concepts for propellant depots. These are water to liquid oxygen, liquid hydrogen depots in Earth orbit, at Earth Moon L1 and around Mars. The one around Mars is based on Lockheed Martin's Red Rock story of having a Mars base and sending water out to transform it into liquid oxygen and liquid hydrogen for the reusable Mars descent ascent vehicle. So I'll leave this up and we'll get into the panel. George, Dave, Edgar, Dan, thanks for joining the panel. Good to have you here. Please turn on your cameras so we can see you, even though you were in a car when we last saw you, Dan. There you are. How are you?
I'm doing very well.
Great.
Thanks.
So questions, let's start off with, let's talk about the similarities and differences between stage refueling and propellant depots. Dave and Dan, I think you were part of that study, and George, what are your thoughts on that?
Hey, well, I'll start off here, I guess. But the idea of the stage refueling was one of the first concepts that I ran across when we were doing some of these studies in the Advanced Development Office at JSC. And our performance analyst pointed out that we could get probably 2 to even maybe 3 times the payload to any location simply by refueling that stage. So that sparked a lot of interest in it. And that actually got me involved in really looking more at propellant depots or stage refueling and different ways of doing those. I was also really motivated by just seeing the other benefits that we could talk about too a little bit later on here. But if these depots are done effectively, or stage refueling is done effectively, or even if we have depots that do more than just fuel but have capabilities that other terrestrial depots like aviation depots, which I worked in, can provide, the benefits are just enormous. So yeah, I mean, I'd like to spend a little more time on those benefits, but basically it's just, are you refueling the stage with another load of propellant from a dedicated propellant launch, or are you bringing a bunch of stages of propellant up together to aggregate them at a depot? Dan, you
Yeah,
add?
let me add in that I actually first came across stage refueling from essentially George Sowers and colleagues, Bernard Cutter in particular.
Yeah.
And I think, that the strategy, crawl before you walk, before you run, really applies here. And stage refueling, okay, really pretty much puts to bed most of the technical risks behind, in space, fuels, gauging, and transfer, and kind of builds the base, in my opinion, for eventual depots. I think depots are inevitable as we move more into space. We're going to need transportation nodes in space, just like we have on Earth. Depots are going to be a part of that. But I think the stage refueling will be the first step. Elon essentially has adopted that at this point for Starship.
Right.
And I think that's where we will see the first activities, and where we'll essentially sharpen our pencils as to what's involved technically, what's involved financially. But that's what I look forward to. And as Dave was saying, if you do the math, if you do the planetary and the payload logistics, there's just no substitute for in-space stage refueling, either simply like what we do with aerial refueling between airplanes, or more capable depot approach.
Right. George, can you talk a little bit about what was behind the ULA distributed launch concept?
Yes. So, when I was chief scientist at ULA, we were studying stage refueling, probably going back 15, 20 years. And, the reason to look at it is just the economic benefit.
Right.
They're tremendous. The concept that you showed, where, you just launching fuel from Earth, it's like another staging event. And so it's a way to sort of cheat the rocket equation. But, just to give you some actual numbers, the 2 launches, one for fuel and one for the payload itself, gives you 3 times the payload performance to the lunar surface. So you get that benefit. Two launches, you get 3x payload delivery. If you start sourcing your fuel in space, the leverage gets even better. I just recently published a paper in New Space looking at the economics of lunar ice mining for propellant. But some of the numbers there are, one refueling of a payload going from Earth to the lunar surface, refueled from lunar propellant, gives you 3x or the performance. So one refueling event, 3 times the performance to the lunar surface. I've done some calculations. If we can use lunar propellant for Mars missions, you can save about $12 billion per single Mars mission, which is, those are enormous savings. If you're coming back from the lunar surface and you can refuel with lunar propellant, the savings are about a factor of 70. So refueling the economic benefits of refueling are just enormous. And, to put it back into the context of depots, a depot is a distribution node for propellant, because each of these refueling events, there's no canonical place. If you're going from Earth to the moon, then it depends on, the mass fractions of the rocket and those sorts of things. It's a different optimum place to refuel. So a depot is a great place to dispatch a tanker that would then meet an upcoming stage for stage refueling. So there's a whole architecture associated with that.
Great. So I'm going to dive in a little bit more in detail on the depots now that we've got that comparison out of the way. So what is the depot impact on space transportation? George, you mentioned a lot. Dave, you mentioned it. And in the studies that I did at Boeing for Constellation, 2 to 3 times more payload to destinations beyond low Earth orbit if you just refuel the upper stage that got the payload into orbit. It doesn't matter where the propellant comes from. You get 2 to 3 times more payload. And when I looked at Constellation and a depot, like one of the pictures you saw earlier, we could see a 33-ton increase in landed mass for Constellation's Altair. It upped it from 18 tons on the surface to 51 tons total on the surface if we refueled that Earth departure stage in low Earth orbit. We can also limit the impulsive stage delta V, that's the energy to move payloads around, to less than 5,000 meters per second with depots at both ends. So our stage size is limited. We don't need propellant. We don't need to carry propellant out to the destination and back if we have depots on both ends. They can support space-based reusable transfer vehicles and landers. They can produce liquid oxygen and liquid hydrogen from water. They allow water to be transported in and around space instead of cryogenic propellants, so that there's no concern for boil-off. They allow mission hardware and propellant to be launched separately. One of the issues with distributed launch, George, and panel is that it puts propellant launch in the critical path of the mission. And if you can separate those two and get the propellant up there first, which is depot allows, and then the payload, then that doesn't affect the timeline of the mission as much. Yeah. And it can also be a strategic propellant reserve in space for response to support responsive operations for the Space Force. And there are multiple depot concepts, as you saw in the pictures that I kind of blew through. There are storable propellant depots. There are water depots. There are water thrusters out there today. There are ice depots you saw in one picture. Cryogenics, that's liquid oxygen, liquid hydrogen, methane. There are water to LOX hydrogen, liquid oxygen, liquid hydrogen depots. There are different gravitational configurations. Purely microgravity, gravity gradient, where the propellant is settled because it's lower in the orbit than the countermass, so that the propellant settles down to the bottom of the tank. There are rotating depot concepts. There's magnetic settling that has been proposed, how to move that propellant to one end of the tank with magnetic forces. And then there are different thermal management approaches. Active heating for storables to keep them from freezing. Passive cooling to keep the cryogenics from boiling off a lot by putting in what's called vapor or broad area cooling shields that uses the hydrogen vapor to keep the oxygen from boiling off. Active cooling, i.e. putting a refrigeration system on the depot to keep all the boil off from happening, to eliminate boil off. And then liquefaction, that is separating water into oxygen and hydrogen and liquefying it there on the depot. And then, what do these depots have to do? From a propellant perspective, they have to receive the propellant, they have to store it, they have to dispense it, put it in the customer's tanks, they have to cool it and or heat it. from a water to liquid oxygen, liquid hydrogen depot, they have to produce the gaseous oxygen and gaseous hydrogen. They have to remove water from the hydrogen. Most electrolysis units end up with water vapor in the hydrogen stream. You have to remove that before you liquefy it, or you end up with ice in your tanks. Not a good thing. And then they have to liquefy that, chill it down, turn it into liquids. In addition, they also have to have the primary satellite functions. They have to have structure, power generation and storage, thermal management, command and control, guidance, navigation and control, communications, command and data handling. And then eventually, like was mentioned earlier, they may be in multiple locations, multiple Earth orbits, in the Earth Moon Lagrange points L1 and L2, where gravity cancels out and satellites can follow the moon around the Earth, but in locations not in lunar orbit. At the gateway near rectilinear halo orbit, where NASA is doing their staging with Orion. We can have depots in lunar orbit, not my favorite place, probably my least favorite place, low lunar orbit. We can have them on the lunar surface and in Mars, on the Mars surface and in Mars orbit. So, and really they're a necessary infrastructure for a true space economy. You know, they remain in a defined orbit. So you can go visit them, you know where they are. They refill transportation vehicles. They're cross-docking facilities, i.e. a place to move payloads from one vehicle to another so that the vehicles can be designed for the environment they're going to fly in. And they can also be a host for payloads and spacecraft between missions. So there have been a lot of studies. We've talked about them, by some of them, but we've all been involved in many studies. So what are the key studies and what have we learned from them? Let's start with Edgar.
Yes, actually, Dallas, that's a perfect chart to segue into that. I'd add the factor of time. Depot allows you to fill up all at once, right? Versus instead of you waiting for tankers, the depot is waiting for you to arrive, right?
Right.
So that's a distinction there that, you know, depending on the business case, will make the depot very attractive,
right,
versus putting up your stage empty, semi-empty with a payload and perhaps adding payload and then having to fill, right? So you're on the front end of that business case, right, waiting for the support and the rest of the payload. Yeah. The depot reverses that. You can gas up and go, right? You fill up like the gas station example that you made. And we did that in, that was pretty much the baseline case in 2011. Dave was there too, Dave Chevron, for the NASA propellant depot study.
Right.
It was to have the fuel waiting for you, the propellant, the oxygen or the hydrogen, the oxygen or the fuel as need be. And we did various commodities too. And that was in 2011. It was very attractive.
Right.
For reasons that were not technical, I'd say it did not go anywhere. That was a time when there were decisions about how to get to the moon, right?
Right.
Path for NASA back then. But it was, I'd say, very competitive, especially on affordability. The issue does arise. You have tankers become expendable.
Right.
But as you pointed out too, the key word is reusability. You could get to the point as you get farther away from Earth, you're going to increase reusability drastically. Right. So there's a certain inevitability to this.
Edgar, do you have any slides you want to share?
Sure. I've just got the one concept, which I think is useful. Let's see how I do this.
There you go.
There we go. So this is a concept that then by 2015 came along, the Evolvable Lunar Architecture Study. And then the idea arose, and this was with some of the same people from 11. Charles Miller, again, was a lead here, just as in 11. the idea was to go direct, right? You can get a tanker to fill a stage directly without a broker in between. And that is also attractive. I think the direction on this, to build on Dan's thought, perhaps one may come before the other, sort of in a crawl before you walk sort of sense. But the business case, I think, will have a lot to do with it too. Do you go put up your stage and payload and then await being refueled, as in this concept that's up on the screen? Or do you try and reverse that, have the propellant waiting for you already with a depot? I think they're both very viable cases. Of course, as you get away from Earth, you are definitely heading in another direction and toward greater reuse. Your tankers are coming back and forth from somewhere, right? As George will point out in his ideas, as you get into lunar architectures and sustainability. This particular concept, I think, is interesting. There's an old photo there, Saturn S4B. Right. And I don't think a lot of people appreciate that. That's pretty much a lunar stage scale for more than just the reason that it actually was a lunar stage. Imagine if you had topped that off. It was partly empty when it would send the Apollo crew and service module and the lunar lander, the LEM, to the moon. It was partly empty already because it had done some burns. If you could top off that scale of stage, I think these are useful numbers here in your 10, 11, maybe 13 metric ton range for dry mass for a stage. If you could top that off, it goes right to that saying that low Earth orbit is halfway to anywhere in the solar system. Yeah. Right? You have got tremendous delta V. And as you pointed out, Dallas, in your charts, your landers can go from the low tens of tons to the mid tens of tons, right? You can get up to 50 tons where you might have been thinking 15 or 20 before. For a lander. And it's because you refilled. You topped off the tank before you headed out on your trip. And after that, it's very Apollo-like. I mean, this is very analogous. I mean, we've been here and done that in a sense. So I find this to be a good way to think about just the basic numbers on lunar stages. Right. Your 10, 11, 12 tons dry, your payload's atop, you could rendezvous a crew afterwards, as you see in step 3. And after that, you're very much into an Apollo-like lunar architecture. But there are many more. I'm sure that NASA is going to get a lot of ideas for LETs, for the Lunar Exploration Transportation Services. And there'll be lots of variations on this, but it's that key step, getting that stage topped off and being competitive with other options. Like if you had a low volume launcher, if you had to build a unique launcher, or why not use launchers that are already used for other payloads and have built up reliability, right?
Sure.
Well, and let me if I could just interject for a second, Dallas.
Yeah, Dan.
I think that a question really presents itself. And actually, when I first got introduced to depots back in the late 1990s, they'd already been studied for a good 20 years, as you note. So the big question is, how come this hasn't happened? And what needs to change to make it happen? Because I think that the evidence for the benefits are overwhelming. Okay, so I think that's a key question. Well, how come this hasn't happened to this point?
Yeah.
And what do we do different now that it actually can happen?
You know, Mike Griffin, when he was administrator of NASA, kind of put a challenge out there in 2005. You know, he said, you know, we have an architecture, we can get to the moon without depots, but if they were there, we would use them, but they need to be commercial. And that was the basis for the whole work that I did at Boeing was, is that a viable approach? And with SpaceX, Falcon 5 and Falcon 9 just coming into their PowerPoint stage, if you will, at that point, and they had posted prices. You know, it was a viable approach that one could put up a depot and sell propellant for more than you could launch it for, given what Mike said propellant was worth to NASA in low Earth orbit. So yeah, very, very true. I've got a question here that is interesting, and maybe some of you have looked at this. Are we looking at producing methane and oxygen propellants in space using water and CO2 shipped from Earth? I personally have not looked at that. Has anybody else looked at that?
There have been some folks that have looked. George Sowers may have some comment on this, and folks at the Colorado School of Mines.
Uh-huh.
Yeah, looking at in the cold trap areas, in addition to CO2, by the way, you do have some level of organics. Okay,
Right.
so there is a potential of using processes to actually generate methane. I still think, though, and initially, it's still beneficial to actually use low cost reusable vehicles to bring either water or methane from Earth to various locations. Now, as time goes on and we see what the resources are off world
Right.
and how easy or difficult they are to access, okay, because we don't know right now. We
You're
really
right.
have no idea about how easy or difficult these things will be to access. But I think depots will happen regardless, because you can, I think a number of your arguments show, it is so beneficial for in-space activities, even if you're bringing all of the fuels and water and methane from Earth.
Right.
Now, if you can get off-world resources, that's just icing on the cake. And in time, we will. Certainly at Mars, you can generate methane. There's no question.
And Joel Sercel at Transastronautica is actually working on how to mine asteroids optically to get all the volatiles off and bring them back to Earth. So, there are off-world propellant suppliers out there who are developing the technology to do that. George,
Yes.
any comments on that? On what Dan
Yeah.
said?
Yeah, well, the direct answer to the question is I'm not aware of anybody that's looked at trying to produce methane from CO2 launched from Earth. I'm not sure why you would do that. It's just as easy to launch methane from Earth,
Right.
and not have to process it.
Yeah, and that's what
And
SpaceX
a lot
is
of people have thought, there's a lot of work going on extracting oxygen from lunar regolith, which
Right.
to me is sort of a backup plan if there's not sufficient quantities of water ice at the poles of the moon. But I've always been sort of a lax hydrogen guy.
Right.
Methane, I think, really entered the conversation. I first started thinking about methane as an in-space propellant, from Zubrin's work on Mars Direct and producing methane on Mars, because you have plenty of carbon.
And that was before we knew there was water on Mars or the moon.
Yeah, and now that we know that there's water everywhere, on asteroids, on the moon, on Mars,
on Mercury,
I don't think methane. I think economically methane is not going to be that competitive. But
so why is SpaceX using it? That's kind of a rhetorical question, but
because I think SpaceX started out with a Mars orientation.
That's exactly. Yeah, I would agree.
Yeah. So if I could go back a little bit to the question about some of these studies that we've done, the one Edgar mentioned, it was the NASA study for depots, and it was I think it was the 34D architecture. But one of the big issues that kept coming up is, well, it wasn't going to be reliable to have all these different flights to bring all this propellant up. It was just too unreliable for that. And so that was one of the big parts I did on that study. Was I got this team together from SAIC. By that time, I'd moved from the Advanced Development Office to Safety and Mission Assurance, so I had the resources to do that. The results of that study basically showed not only was that not correct, that the assumption that it was going to be lower reliability, it actually was more reliable.
Right.
Yeah, I see Edgar's got that highlighted in there. The thing that people were getting wrong was that you had to have, if it was 10 launches of propellant, you had to have all 10 had to be successful. They all had to rendezvous, the dock. Docking was going to be risky and complicated. Well, how many dockings have we done with station? And well, there's finally been one incident of a docking that didn't go too well just this last week or so. But I mean, we know how to do the docking. It's not that unreliable to dock. But if we have contingency missions, we have, like, if we need 10 launches of propellant to launch enough propellant for a Mars mission, let's say, you do 10 out of 12. You plan a couple of contingencies in there.
Exactly.
And the the theory of that in reliability terms is M out of N. It's how many out of how many it takes. And we did a lot of study on that, both in the 34D study and then in the evolvable lunar architecture study that showed that actually the frequent flights was a feature, not a bug. That was one of Charles' favorite comments. It actually allowed you to get experience in launching stuff. You could take new vehicles, you could mature them with a low criticality payload. Basically, it's water. So if it goes back in the ocean, well, it was water anyway. As long as you have the backups of having the contingency flights, preferably on a couple of different vehicles at least. Then there's things like the potential for a safe haven. If the depot is a safe haven for any kind of problem and can provide power to the vehicles that are going to be going on, that actually improves your safety and your reliability.
Yeah.
You've got the frequent launch is good for human reliability, for personnel proficiency, for ground crews, for the people that are building the rockets and systems, the flight controllers. And then with the alternate methods to supply the propellant, you don't necessarily have to have it all come from, say, the moon or all from the Earth. You can have different sources of
or all from one launch vehicle.
Or all from different launch vehicles. And that gets into a whole nother thing of if your launch vehicle doesn't have to be optimized to carry as much as possible because it's got all its propellant with it, then you can optimize that vehicle for different things, like having more safety equipment. We looked at things like medical kits. The original 34D study, the baseline was, well, the crew would basically have an ISS medical kit. Well, if we weren't launching propellant with the SLS, but we were launching everything that we really needed, we could launch a real medical facility.
Right. So do you have anything to share slide-wise, Dave, to enhance our discussion?
Well, actually, I could share different things. I've got several different things pulled up here. What I was thinking about, if we wanted to go into some of the other studies, the evolution depot testing and evolution, I've got an interesting chart on that. I guess it just depends on where we want to go. I've got some charts on how the M out of N actually helps. What do you think, Dallas?
I think to stay at the top level, George mentioned a study he did and published in the recent journal. George, talk about your concept you did for the Space Force.
Yeah, so a very recent study that we just completed was a partnership between the Colorado School of Mines and a small company in Golden, Colorado called Lunar Outpost. We did this study under an Air Force grant, so it's kind of interesting that the Air Force was interested enough in propellant logistics to fund a study. I have a couple of charts I can show that put a little bit more meat on the bones. Hang on a second.
There you go.
Everybody see that?
It's coming. Boom, it's there. It's a little.
Yeah. All right. So I think about a depot as being part of a larger architecture for, producing and distributing propellant within cislunar space. One of the things we learned early on in the work that we did at ULA is that the optimum point to refuel a stage depends on everything. It depends on the rocket itself. It depends on where the stage is going. And so there's really not a sort of canonical place to put a depot where the stage would visit the depot. So the idea here is that you're mining and producing propellant on the lunar surface from lunar ice, in the vein of Joel's asteroid mining. You're mining near-Earth objects, near-Earth asteroids for water, bringing those back to a central distribution node at EML1, where you have propellant refining and storage. And then from there, you're dispatching propellant tankers into Earth orbits.
Hey, George.
Yeah.
Let me interrupt. I only see about 80% of your slide for some reason.
All
Yeah, if you
right.
can if you can reduce your Zoom there a little bit, George.
I'm not sure why, but it extends off to the right of my viewing screen.
All right, that's weird. Let me stop and try it again here.
Maybe I don't know, share presentation or don't go full screen presentation mode.
How's that?
That's much better. Thank
yeah.
you. Thank you.
All right.
Yeah.
And now we can see what you're talking about.
Yeah, so this is just sort of a schematic of the overall architecture, but you're producing and producing propellant on the lunar surface. You're shipping it to a depot at EML1. You're mining propellant or water at a near Earth object, bringing that back to EML1. And then your use cases are you're doing stage refueling with propellant tankers that are meeting, outbound stages from Earth at whatever optimum point that they want to be met. And those are typically orbits that are kind of like a GTO. They're highly elliptical. We did some optimization studies looking at the optimum place to refuel on the way from Earth to the lunar surface. And that was a very highly elliptic GTO type orbit. And then the other use case is refueling satellites in geosynchronous orbit. And this use case is in particular, I think, interesting to the Space Force, leading to, if they can refuel some of their assets that are in geosynchronous orbit, then you can maneuver. One of the things that limits the amount of maneuvering you can do or moving a satellite around is that fuel load. And if you're limited to what you launch on the initial deployment of a satellite, then you really have to think hard about maneuvering to get, say, a satellite over theater. If there's a hotspot on the Earth and you want to move an asset around, it's what the Space Force calls maneuver without regret.
Right. So
that's the idea of these satellite servicing vehicles that are going back and forth between EML1 and the GeoBelt.
In that regard, George, my initial thought when I hear this is, but satellites don't use oxygen and hydrogen. So in your paper, you pointed out that really it would be a reason for satellites to move to water thrusters as opposed to their current thrusters. So talk about that.
Yeah, so most satellites today in geosynchronous orbit use hydrazine or some sort of storable. People are moving to electric propulsion, which have sort of exotic fuels, iodine or xenon or something like that.
Right.
Those would be candidates, I think, for storage at a depot. But if water is on the moon and water is in near Earth asteroids, then we have an abundant source of water in space. So water as a propellant then becomes a viable option. It becomes very, very low cost.
Right.
Where something like xenon or iodine, you would always have to launch from Earth. So, I think that's, I can see a time in the future where, everything propulsion is sort of water-based.
Right. And there are three.
You can have steam-based propulsion.
Right.
There's a company called Deep Space Industries that was bought out by Bradford Space, has developed steam-based thrusters that have been actually proven in space. And then you have companies like Momentus that are looking at plasma-based that
Right.
get you even higher ISPs. So all of those things become options in a sort of water-based economy.
Right.
And then if you want really high thrust, then you separate the water into oxygen and hydrogen and liquefy it.
Right. And all this is possible as long as we can get the water in space cheaper than we can launch it from Earth.
Right. Right. And that, that gets back to the economics of water mining. And I've done a lot of work on that.
Right.
This was sort of the architecture concept we had for an initial depot at EML1. It sort of is that backbone of this distribution architecture. It has water to LOX hydrogen propellant refining. So electrolysis and liquefaction, that's that module in the middle there that has the US flag on it. You have both water and LOX hydrogen propellant storage. The LOX hydrogen is on the right-hand side, and those sort of, bronze gold colored. In my mind, those are repurposed ULA ACES upper stages.
Right.
That were used to launch the hardware into EML1. And then you just leave the stage there to turn into a storage vessel. You've also got transfer to these tankers and then transferring water to satellite servicing vehicles. And you mentioned spinning and passive cooling, so this architecture is entirely passive. With passive means, you can get down for hydrogen boil off to less than 10% per year, which is not that much especially if you're moving propellant through the depot. You don't want to be storing it there for a year. So it sits behind a sunshade that's always pointing at the sun. You mentioned spinning, so the right-hand side of this thing is spinning because you can store propellants, cryogenic propellants, better in a settled state. And then you can also transfer them much better in a settled state. And the same thing for the water side. And then you mentioned all the other functions that the propellant depot would have, and all those are down here. We also included, the idea that, if you have a fleet of tankers and other satellite servicing vehicles, then those themselves would want to be serviced.
Right.
So we have servicing bays for that. So this architecture was developed, as part of a study for the U.S. Air Force. We also created a sort of modular, Dan Rasky's question of how do we get here from there? We kind of created a modular buildup that, added functionality over time in various stages. And, started out actually with hydrogen propellant storage because, most current satellites in GEO use hydrogen. Some of the key technologies, the passive cryo storage, things like the sunshade, you use hydrogen to cool the LOX, so you have zero LOX boil off, advanced multi-layer insulation, settling via the transverse spin, using LOX boil off for both vapor cooling and attitude control. So my opinion is you don't want zero boil off because you need attitude control anyway. And you can use that hydrogen gas that's boiling off for vapor cooling as well. The cryo fluid transfer, no vent fill is something that's been demonstrated on Earth.
Right.
One of the encouraging things about how do we get there from here is that NASA just within the last year has invested over $300 million with ULA and Lockheed and others to do in-space cryo transfer demonstrations.
Right.
Which is one of the key things. And then there's also money that's being invested in the propellant processing. And there's a lot of work in fuel cells because if you have LOX hydrogen and water, you can go both ways. You can go from water to LOX hydrogen, and then you can go back the other way if you need electrical power in large quantities for some particular reason.
So George, I'm curious. You've got liquefaction on this depot because you're processing water to liquid oxygen, liquid hydrogen, and yet you still have passive or boil off in your tanks. Why not route that boil off back to the liquefaction and not lose that propellant?
Well, so losing it has utility, right? If you're not wasting it, if you're utilizing it for vapor cooling and you're utilizing it for attitude control, then it's not wasted. So if you don't use hydrogen for attitude control, then you've got to have some other fluid on your depot for attitude control.
But you could tap that off before you liquefy it and store it as a higher pressure gas.
Yeah, now I mean, all those things to me are kind of details and how you do the nuts and bolts of an actual architecture.
So
But
I
the
think,
encouraging thing is that there is active work ongoing on all those technology fronts.
yeah, so I think one thing that might be interesting, if you wanted to let me share this, I've got this depot evolution strategy that we had
Right.
worked on. So let me see if I can share. Oh, that's
Should
only,
be
it
able to.
says only the host can share this meeting. I may need a permission there, Lee.
That's odd, Edgar.
Yeah.
And
It must be your
I-
other computer.
It's my other one. Yeah, the one I said I'd be sharing screen from.
Okay, let's make you a co-host there as well. It might take
Okay.
a minute here.
Yeah, so what I wanted to show on this, it's actually a detail of the poster that I've got behind me. But we put a lot of, I'm still getting that message. But anyway, we put a lot of thought into how we could basically evolve the capability to do depots. And the thinking back then, actually the gateway was supposed to be a propellant depot. Like the current gateway is not really seeming to be focusing on that capability. Still getting that message, Lee.
Yeah, I don't know if I can, maybe I can do it.
Well, while you're
Yeah,
working
but-
on that, I've got a question for Dan. I
Sure.
think-
Can you
I
hear?
think he's
Can you
back.
hear me?
Yeah,
Yeah. Can you hear me?
yeah.
Okay. Yeah. Hey, I got
So
logged
Dan,
off.
do you
You
think
should have both screens now.
do you
Sorry,
think
Edna.
SpaceX negates the need for depots, the SpaceX Starship?
No, just the opposite. I actually think that, okay, there's three things that are different. I was actually thinking about three things that may allow depots to actually now happen. Okay. And those three things are, first, the NASA Artemis program, which is intended and stated objective to return to the moon, but this time to stay. Okay, not just new flags and footprints, but to stay, which means infrastructure. Okay. The second thing has to do with the interest, and George mentioned it, with the DoD. And
Dan, your audio is not so good.
one of the strengths that DoD brings is structure.
Well, he's having trouble. David, you should be co-host
Yeah.
on both
Okay, yeah,
accounts
sorry,
now.
it's just
Sorry about
dragging.
that.
Okay.
Yeah.
Sorry, Dan, you want to try real quick once more, or shall I go?
Let me just finish off. Can you guys hear me?
Yeah.
And then the
now.
third one is commercial. Commercial, again, is very interested in the bottom line. Okay. I think those three things open on SpaceX, I think, is an important part of that.
Yeah. Okay.
Okay.
Thanks, Dan.
Yeah, thanks, Dan, and thanks, Lee, for getting that solved. Yeah, so this was what we were working on for how we could start, and basically some things we could do would be, starting with some ground testing, having some demos in ISS. We've had a little bit of that. This is
There's been a lot of that since
there's
2012.
been a lot since that. Yeah, this was a plan that we were working on back in around 2005.
Okay.
So, just kind of going back to that history though, but getting a LEO fuel depot, just bringing propellant up from the Earth where it's not as risky as having to go out to the lunar surface and do mining and all that yet. Coyote was one of the old concepts at that time, but we basically had the strategy of taking this, getting it further out, going out to EML1 with a depot, having a geo fuel depot, and then having servicing to go on out to Mars from there, eventually getting the ISRU from the moon. It basically, you can see there was the L1 gateway was to be an in situ resource utilization supplied capability, but there was a lot of thought was put into how we could do this effectively. And the objections that have been in place, I think we're starting to finally get to where we're getting past some of that. And with that, I'd really like to maybe go with what can we do from here? How do we finish getting into, having real stage and then depot capability, and what can we do with it? What new business models
Well,
are open?
Dan kind of touched on it, and the lunar exploration transportation services opportunity, with NASA buying services from the gateway to the moon and wanting reusable landers, that's really a reason to have depots out in the NRHO gateway orbit. Because those landers will need to be refueled, and they will need more fuel than we can get out there on commercial launch vehicles in a single trip. So,
yeah.
But the biggest thing is there needs to be a customer, and now the LETS Lunar Exploration Transportation Services providers will be a customer for propellant at the gateway around the moon.
Yes, that's an idea, Dallas, that we haven't perhaps touched on enough, which is NASA as an anchor tenant.
Right. Exactly, and so
your tendency too it's a commoditization of the most significant mass that is in this diagram. It's propellant. Right. So you're trying to commoditize something that invites a broad audience, a broad sector of the industry in to participate.
Right.
Versus saying, can you can you build this very particular payload for me? That's a different sector of the industry. Here it's, can you get me some liquid oxygen to where I need it, right?
And in order to do that, one may need or want a depot in low Earth orbit to fill up the stage that carries it out to the gateway and comes back and does that again and again and again. So there's kind of the seed for getting this reusable cislunar transportation architecture started.
So Dallas, you may recall back in 2016, the idea of being a customer. In 2016, I approached at the Space Resources Roundtable with Golden. I actually publicly, as chief scientist of ULA, offered to buy propellant, and I offered to buy it, at L1 or on the surface of the moon,
right?
And provided a price I'd be willing to pay.
Yep.
It stimulated something. It stimulated a lot of discussion. Since then, I think, I spent a lot of time trying to convince NASA to do the same thing. Just put a price out there for propellant, and it would stimulate some commercial interest.
It would, and
I think the Space Force could do the same thing in the context of a strategic propellant reserve. The Space Force could offer to buy propellant. I think having some U.S. government agency step in would be more powerful than having a commercial company.
And even not necessarily buying propellant, but buying the availability of propellant.
Yeah, you can think of options or commodity options,
right.
Or things along those lines.
And commoditization is, I think, a good word, because if you have a habitat that may be a commodity very far away. One day we will have so many we can't keep track. But the most immediate thing, which is most of the mass, if you're moving around a lot in cislunar space, which we want to be, is propellant.
Right.
And it's, liquid oxygen is liquid oxygen is liquid oxygen. So it lends itself to be commoditized. Maybe one day we'll commoditize the trip, the spacecraft, the habitat, the land, but the more immediate thing that can be commoditized is very much about depots and refueling. It's the propellant.
Yeah, no, I look forward to the day where water and or propellant is a commodity, in the sense that the only thing that matters is where you can buy it and what the price is.
Exactly.
Right, just like your gas, it doesn't matter where it came from.
Yep.
It can come from Earth. If SpaceX wants to provide it cheaper than you can get it from the moon, that's fine. It comes from the surface of the moon. It comes from near Earth asteroids. It comes from anywhere you want, right? When we pull up to a gas station, we don't care whether the gas came from oil from the North Slope of Alaska or West Texas or Saudi Arabia. We don't know. We don't care.
Yeah,
We just want to know that it's there and what the price is.
Yeah. So one thing I did want to touch on maybe before we leave is the basic premise of the evolvable lunar architecture, which was for NASA to put out an offer to purchase propellant for the Mars missions and have commercial companies provide that propellant, basically taking the savings that they could get from having to launch all the propellant from the Earth with the SLS, and then use that as an incentive to get not only that anchor customer having that part of it, but to see what other kinds of uses could develop out of that.
Yeah. So Dave, you're sharing something. What?
Yeah.
What and why?
Well, I was going to show the number of depots that were shown back in this integrated space plan, the 100-year space plan that Rockwell and Ron Jones had put together. I was back at Rockwell back at the time this happened.
Yeah, Ron was a colleague of mine at this time.
Yeah. Well, I was working in space station at the time, so I didn't run into him until a little later
Yeah,
on.
we were both in advanced programs.
Yeah. Well, I was figuring out how we'd maintain the space station, and then that was a big challenge with
Right.
with EVA and all that. But yeah, then I ended up at NASA doing the testing on it. But yeah, I was just going to show this is what it's from from Ron's integrated space plan. But yeah, if you look back, the images I shared earlier were showing the number of different depots and stage refueling and so forth that show on this integrated space plan. And I think it's worth going back to look at some of that sometime, because it really was, I think, a very well thought out plan. We're nowhere near as far along as we
Right.
had hoped we'd be back then, but
Yeah.
it's very very encouraging. It's very encouraging at the time to see people actually thinking about that
Right.
kind of.
Yeah, this was part
stuff.
of the space. This came out of the work that was related to the Space Exploration Initiative and the space transportation concepts, and it was called STICM. That's the abbreviation. But anyway, I'm surprised Lee hasn't kicked us off the channel yet.
Yeah, I
because
think
we're overrun. So
I think
thank you,
it's
Dan.
our
Thank
time.
you, Edgar. Thank you, Dave. Thank you,
Thank you,
George.
everybody.
And appreciate your participation and your comments.
Yeah,
Thanks.
and
It's been fun.
I guess towards the end maybe there'll be some more time, Lee, if at the end of the event, if you want to have the open,
Tim
little
has
more
said
open
that
discussion.
for anyone who's able to stay, we can cover just a few more questions if you'd like.
Okay.
So, and there are some
So-
additional questions in the chat, and then Kevin Russell has raised his hand as well.
Yeah, I
Dave,
think
why don't you stop sharing?
we've addressed some of the questions. Nuclear power plants were asked about. Yes, they can replace the solar arrays. There's still the issue of heat rejection. Has anybody considered stratospheric airships being rocketed from the stratosphere to higher altitudes? Isn't JP Aerospace doing balloon launches? But they're typically small payloads. But I'm not sure about the scale we would need, if anybody's looking at the scale we would need. But then how do you get to the stratospheric airships? There's still that first stage. It's just a different kind of stage. Big fan. So at JP, yeah. So Lee, did you have any other questions that you can see? I think we see them all here.
Yep, just the one person who'd like to ask one.
Oh,
on
okay.
screen.
Yeah.
Is that all right?
That's fine. Yeah,
All
I'm
right.
sorry, I didn't see the hand.
Kevin, take it away.
Hey there. Can you hear me okay?
Absolutely.
Okay. My first job was at a coal tipple. And we were between the mine and then we weighed it, crushed it, and processed it, and it was shipped off to TVA. So the customer, the government, was buying the energy.
Right.
And this was not far from Oak Ridge, Tennessee, which I last night found out that Vannevar Bush under Roosevelt basically took the IP away from the scientists. They all had to sell it for $1 for the isotopes, for the fuel for the first atomic bomb.
Yep.
That was, and my question is what is the IP situation right now in space as corporations and scientists develop depot and energy innovations that would protect them from the government saying, no, that IP is ours. Even if they fund it, but they claim, if they do what Vannevar Bush did to the scientists at Oak Ridge National Laboratory. So that's my question.
A lot of the contracts have IP clauses in them, and NASA can use IP that they funded or partially funded for their own purposes. And sometimes those own purposes are to share that with other companies. But all of the IP that we need, all of the capabilities that are needed to create any of the depots we talked about today exists in companies' hands, whether that's been developed through NASA contracts or Air Force contracts. But it's available. And to me, the right thing is to go to those companies and get them and buy their technology to incorporate into the integrated system. But NASA's not NASA today, in my view, nor the Air Force, are going to build and own depots. They're going to buy services that use depots, perhaps like they are for the Lunar Exploration Transportation Services. But thoughts from anybody else on the panel?
Yeah, I mean, I agree with Dallas. I mean, if you're working for NASA in whatever capacity, if you have a research grant or a contract to produce hardware, there are IP clauses on your contract. And my advice is to get a really good IP lawyer to look at those to make sure you're not going to have the government coming in and taking away your secret sauce.
Yeah.
And that has happened. I mean, NASA has been known to do things like that.
Leveling the playing field, as we call it.
Yeah. Right.
Well,
So you have to be really careful as a private company. But
and SpaceX is a good example that Elon's done a great job. He's retained them all for Starship and all these other things. So proof in the pudding.
Yeah.
That's an ingredient of partnerships versus cost plus. And in either case, even when you do seed rights, it's only for the government to not have to pay very often not to have to pay just the royalty, but someone else who does it would, right? And the government contracts out. So it's not as inhibiting as it might seem. And partnerships get around that entirely. It remains with the company.
Yeah, the public-private partnerships do tend to leave the technology in the company's hands.
Mm-hmm. Yeah.
Right. But on the other hand, if you want the safety of a cost plus contract, and a lot of contractors do, one of the things you'll have to give up is at least government purpose rights, which means the government has the right to use the data for any legitimate government purpose.
Right.
You can't hand it to another commercial competitor, but they can use it for whatever they want.
Exactly.
And, if you ever see government purpose rights on your contract, try and get that changed.
Gentlemen, thank you very, very much. I appreciate you doing this panel and sharing your expertise like this. It's not every day I get to be a fly on the wall for a conversation with people who've made such a big impact in this space.
It was a pleasure, Lee. Thanks for asking.
Thanks.
Yeah, thank you very much. Enjoyed
Dave,
it.
thanks for spearheading this.
Yes.
Okay.
Also, good job, Dave.
All right. Well, thanks for letting us do this, Lee, and everybody that participated in it. Sure appreciate that.
We'll do it again.
We got to figure out. We just need to figure out how to really get this thing moving, and because it is, as Charles used to say, this was probably the single most important thing to developing a space economy, is having propellant depot capabilities.
We are trying to make that happen at CSDC.
Yeah, I totally believe that. So anyway.
I feel like that line, we can get to the moon without depots, but if they were there, we would use them, said a lot. All right. If you have enjoyed the programs so far today, and we've certainly seen the chat light up in this past discussion, Please help us cover the cost of Conversations for the Future events by sponsoring our next event at registration or by making a donation at www.f4f.space. That's the number 4. Now it's time for a conversation between Tim Chrisman, Executive Director of Foundation for the Future, and Morgan Muchnick. I'd call Tim our fearless leader, but the only thing he fears is sluggishness in developing space infrastructure. Morgan Muchnick founded the M2 Group in 2012 after more than 15 years in Congress and the private sector. I think he is on vacation with his children, and we can hear that today. He's an expert in government and public affairs, and he previously served as professional staff to the Senate Homeland Security and Governmental Affairs Committee, where he played a pivotal role in creating the Department of Homeland Security. In addition, he managed the Aerospace Defense and Homeland Security portfolios at the American Institute of Aeronautics and Astronautics, and was a co-founder of Fantasy Politics, LLC, a civics-minded educational game patterned after fantasy football. Morgan, thanks for being with us.
Yeah, so please bear with me as Tim leads this call. I am at a very fun, big pool with my kids, doing my best here, but I was excited to jump on the call with y'all.
Yeah, no, it's great to have Morgan here. What we wanted to do is take a little bit of time here and chat about sort of the current scene here in Washington, D.C. Those of you who are news junkies may have noticed that about an hour and a half ago, the Senate passed its infrastructure bill, the first of likely 2 that'll be passed this year. The House looks likely to take that up later this summer. So all in all, it's been a fairly active year for large congressional action around spending money. I think we're up to almost $7 trillion last I checked, Morgan. And
yeah, that's where we are now, but
yeah,
I find that number to be in the thousands of trillions. I say that slightly facetiously, but go on, yes.
Yeah. And so between this package that just passed, which is about $1.25 trillion, and the next one at 3.5 trillion, we're easily clearing 10 trillion in about an 18-month period. But one thing I think that is really important to highlight is while there's not been a lot of movement out of either the House or Senate science and space committees, there is a lot of bipartisan activity around just bills in general. And that's not something we've heard or seen in sort of the popular press, but like the bill today that passed was as close to unanimous as you get in major legislation, almost 70 senators voting for it. So there is an appetite to make some big investments in major programs here as the U.S. emerges from COVID.
And I would just add just one thing very quickly, Tim, to that point, is that the space issue, thanks to groups like the Foundation for the Future and some others, is starting to get a lot of idea that infrastructure, we're not there yet. Definitely past the sort of crucial 50%. I think we're closer than we are not close on getting pretty universal buy-in. So you may not.
You're breaking up there a little bit, but what I think you were talking about is how there does seem to be a nearly universal buy-in with a lot of what we're talking about up on the Hill.
Yeah, sorry about that, Tim. So I'm just trying to find some spot where not a bunch of kids screaming by the pool. But yes, but my point though is that we're starting to get a really nice place in terms of the buy-in amongst senior folks on the Hill that space infrastructure is critical infrastructure.
Yeah.
And that is incredibly important. It may not bear the fruits we'd like it to for this iteration of this sort of mega infrastructure bill, but I think we're in a really good place for the next round. I really think that we're starting to get pretty darn stable group of supporters who are starting to understand that space infrastructure should be part of the general understanding of what is American critical infrastructure. And part of that is the growing bipartisan understanding of China as a galvanizing support for American sort of growth in the space infrastructure sector. It's sort of really coming together in a very nice way for us. It's past due, but I think we've turned some really important corners on that. Thanks to Tim and people who are really hustling quite a bit to get that word out.
No, and I think that's a good point, and something that, especially any investments that can be made that create jobs on the ground or enable long-term economic development for and or in space are really starting to generate a lot of momentum. At a recent town hall with Representative Beyer from Northern Virginia here, he repeatedly told the space companies and groups on the call, look, if you know of something that can enable your operations, if it's a road, if it's a bridge, if it's a port, those are things that right now fit into the infrastructure bill that just passed. He said, let my office know so we can carve out things for your company, for your projects, because just sticking to the definition of it needs to be on the moon, it needs to be in orbit, is too narrow. And so that is an encouraging thing that we have started noticing, that the Congress people are connecting the ground up, and that's that I think is really important.
Yeah, so I would encourage everyone on this call to kind of keep a close eye on the movement of this legislation. Keep a look at how the House handles this. If anything, the House is going to want to make this bigger, not smaller. And their pushback will be that it's not big enough. So there is clearly a mood, especially in the next year and a half, of doing big, whether it's good or bad, and that's up to everyone to decide on their own. But there's definitely a mood of doing big, broad, government-led spending efforts to take some steps forward.
Yeah, no, and I've increasingly in talks with people within the Beltway here have started realizing that there's kind of a gap in capabilities for those of us in the space community that a lot of other sectors have. One of them is a dedicated trade association for space finance that can do a lot of the advocacy work on non-science and tech committees, so like the banking committees, the financial services committees. That's something that a lot of other sectors have, just because a lot of times there's large sprawling trade associations for institutional investors and the like. And so that seems to be a gap right now. We're in talks with a bunch of different groups and companies to figure out how to fill that. But the other is, and it's sort of a artifact of how the political system is right now, that there's no political action groups for space. There's no, and I mean, there's a lot of hype about these as dark money and corruption in politics. And no doubt some of them are over the top. But in a lot of cases, these are essentially industry funds for investing in political action. And so think of it like an impact fund that might be done for philanthropy, but it's done for political action to support candidates who are supporting issues that are meaningful to that sector. and running ads and support. And I was asked by a couple of family offices last week, who was doing the one, where were the space versions of that? Yeah, I don't think any exist. And it was really interesting to sort of sit down and realize.
And to that end, Tim, I think this might be a good way to sort of dovetail a little bit into the fact that, you know, the foundation is actively planning now for a really, really neat event that we're going to do in the fall. God forbid there's some sort of new round of lockdowns or awfulness that's coming. But the idea is to do our first formal event. And part of that is going to be to honor and recognize some of the congressional leadership that really sort of understand the nuances and the importance of what we're talking about. Because what we do at the foundation isn't so much like space exploration is neat, because there's a lot of people that think it's neat. There's a lot of people that advocate for it. But we're talking about something much deeper and much more important in the next 50, 75, 100 years of American leadership, which is sort of changing the paradigm and understanding space infrastructure as a way of thinking about American leadership in blue collar, private sector, innovator driven, new way of thinking about the space. And that it's not just 7 or 8 people that are in the astronaut training program. It's not just about 3 or 4 billionaires that are competing with the most interestingly shaped, let's say, ships that are going to space. This is going to be thinking about how do we create a real set of infrastructure priorities for America over the next 75, 100 years, just as important as the infrastructure of the internet has been over the past 30 or 40 years, and just as important as the railways and the system of roads we had 100 some years ago and the like. You know, not everyone understands it at that level, and some do, like Congresswoman Salazar and Representative McCallum are some of the folks we think we're going to be honoring. So bipartisan leadership that really see that we need to sort of pivot and really lean forward on these issues. Pardon all the cliches I'm using, but it's extremely, I think, relevant in this context.
No, it's exactly right, because you know, we just saw in the last panel looking at sort of 100-year plans for space that were developed in the late 80s that speak to a lot of that, a lot of what enables that sort of program are those fundamental building blocks that may last for 50 plus years. And those are the sort of highway trust fund equivalents that can continually invest back into the space economy in meaningful ways. And so, like when Representative Blumenthal talked a few weeks back about space tax, a lot in the space community immediately derided him, jumped on how he was just trying to sort of penalize the rich. And I don't know his intent. I only know what his public comments are and what he told me. But we immediately went to his office and engaged and actually met with the congressman to talk about, hey, this, if it's done like the gas tax is done in the US, where all of the proceeds are dumped into a fund that gets reinvested into the community, into that basic infrastructure to support a space economy, that is a fantastic plan. If it is a sort of luxury tax that gets thrown into a slush fund for Congress to use, that's a very different sort of proposal. He and his office were very receptive to the idea that we need to be reinvesting the early proceeds from these high net worth individuals going to space back into long-term development, much like how their ticket sales are essentially paying off the research and development from these companies. And so it's those sorts of long-term initiatives that I think we need to continue to be amplifying. And yeah, the fall gala and award ceremony that we're planning, we're We'll have a couple Congress people. We've already got Bucky Butow from DIU and Trent Edwards from MGM Works, who are going to be two of the speakers, talking about how to bridge the civil and the military and the long-term mechanisms that the space community needs and is developing to be able to challenge China and ensure that the US is able to maintain its place in the coming decades.
Part of, and Tim may have already touched on this earlier in the day, but part of what, you know, drove, and I'm sort of speaking for Tim a little bit here, and you can sort of tell me if I'm wrong on this, but a lot of what's driven the sort of the initial passion behind this project going back a year or so is that America is the best country in the world, but sometimes we get really caught up in the back and forth and the nonsense of the political theater. And we need space to be sort of separate from that. And what I think what is so smart about what the foundation is doing is that we're trying really hard to make space infrastructure funding separate and distinct from the nonsense that dominates the sort of political rags here inside the Washington Beltway, where I'm based and where Tim is based as well.
Yeah.
So creating funding vehicles that are more akin to funding vehicles for American old-fashioned, non-sexy infrastructure makes much more sense so that we can keep ourselves on a glide path towards success and not have these major pullbacks or get 75% into building next generation space transportation vehicles and then cancel it and then debate whether we want to restart it or then whether we want to use Russian ships or then whether we want to rely exclusively on SpaceX. I mean, this is not what a first world leading country does. You know, we need to be the person, the country, this symbolic star leadership of this world, not sort of every couple of years scrambling because Republicans take office or Democrats take office or this president likes this program or that president doesn't like that program, right? We need to make this strong, stable, secure so that investors and innovators and entrepreneurs at all levels, big, small, and medium, all want to participate and all see a path forward for the possible success. Doesn't mean everyone succeeds. That's true in any sector, but it means that at least it's going to be similar to any other industry sector where you're going to succeed or fail based upon, you know, the strength of your ability, the strength of your business plan, and a little bit of luck sprinkled in, and how much hustle you have, and that kind of thing.
Yeah.
Great points. Yeah.
Yeah.
Tim, you want to close it out?
No, I think that was good. We've already stolen a minute from Kevin, and based on the face he's making in his profile picture, I do not want to take any more.
But everyone
right,
keep a lookout, though. We'll send out some information about the event. I do think everyone on this call would probably find it interesting, and
Yeah.
we anticipate having some really interesting back and forth with some very interesting people and leaders in the government and the private sector as well.
That'll be terrific. Thank you so much, Morgan and Tim. We'll see more of you later. All right.
Thanks, everybody.
Our next segment is Saturday Space, where we enjoy things you might do on a Saturday in space. This is our first Saturday Space with a sports flavor. Kevin De Bruin is a former NASA rocket scientist turned professional space educator. He is a host, TEDx speaker, and author, and he educates about space events at events around the globe. Kevin worked at NASA JPL designing spacecraft before falling in love with science communication. He decided to leave NASA and dedicate himself to educating and inspiring others in science. Kevin, the screen is yours.
All right, thank you, Lee. Really appreciate that. Hello, everyone. Thanks for being here and tuning in. I'm going to share my screen, go through some fun stuff about the journey, and then we're going to really get into the fun stuff, the sports, at the end. So let me see. Got to get to the right spot.
While he's doing that, I'll just remind everyone this person was suggested to us in the survey, the feedback survey. So great connection there. Give us your feedback and we will listen.
All right, thanks again, Lee. All right.
We can see your slide just fine.
Good to go? All right. Awesome. So just FYI, down there in the corner of that photo there is a liquid nitrogen. We did a fun little photo shoot for one of my projects that I was doing last year, and liquid nitrogen is just so much fun. But what I want to talk to you about is just a little bit about who I am. So my journey getting into NASA, why I left NASA, and like what I'm doing now. And then that's where some of the sports stuff come in. So I got a couple of highlights here that I like to show. Is I was the face of NASA for a little bit under our people. And then they have a little bio for me. On the right-hand side, you see there me being a systems engineer, something that I can like point people to and say like, yeah, I really did work for NASA. I don't just talk about it. Here's some of the proof. But so the reason I work for NASA is because I saw October sky when I was 10 years old. And yes, it was the VHS that I have right here next to me. Still carry it with me today. And I knew at that point that I wanted to design spaceships for NASA. Now, it took me over 150 applications over the course of 3 years to get my first NASA internship. I was working at NASA Langley in Virginia. And then I realized I was an undergrad at this point that I needed to go on a grad school to really get an advanced degree in aerospace engineering to have a shot at a full-time job at NASA. So I wanted to go to Georgia Tech, but I applied and was rejected by Georgia Tech. And actually within 3 weeks, I was given full scholarship tuition to cover all my tuition and a stipend to do research on top of that. I called around to all the professors, just asking them like, hey, is there anything we can do? Talking with the dean of admissions, wondering where I fell short on my application, how I can improve and submit for next semester. And eventually it all worked out and I got into Georgia Tech. So then I set my sights on NASA JPL and I went through 3 rounds of interviews with them, the last one being 8-hour interview on site, and I didn't get the job. I'm 2 months away from graduation here. I'm like, what do I do? So I was able to get a 10-week temporary internship. So I graduated without a full-time job, got this 10-week temporary job because I was doing research with JPL in grad school to prove to them that I belong. And if I didn't get the job, it was either moving back home or becoming a beach bum. So I set up over 30 interviews for myself in that time, where like I'm on site, making things happen, getting my foot in the door, trying to get both feet in there. And then on the last day of my internship, I was told that I would be receiving an offer in the coming weeks. So then like I went home and I'm waiting at home in Wisconsin, which is where I'm from, for 3 weeks until I actually get the call saying, hey, here's the job offer. And then I had to take a screenshot of me actually clicking accept offer from NASA, which is like a surreal moment where I achieved my dream job. Now, I like to share this story to show that, not everyone has it this hard to get into NASA. Some people have it a lot easier. Some things are a lot smoother. I grew up in a small town in Wisconsin where people laughed at me when I said, I want to work for NASA. So I want to share this story to prove that it's not impossible. I met with a lot of no's, a lot of rejection, but I just kept on pushing through. So if you are dedicated, if you believe in yourself, you can make it happen. I don't believe that no is a real response. It just means not this way, not right now. Back up, take a couple more attempts in a different way. So I actually did write, here's a little plug, I did write all of this in a book, just my memoir detailing everything getting into NASA and beyond. It's on Amazon and Audible. You don't have to read it or buy it, but just, it's there. So space educator. So why did I leave NASA? I just went through that incredible journey of all the rejection and I'm like, all right, bye. Well, I fell in love with educating about space. This newspaper clipping is from my hometown newspaper. After I did my internship, my teacher asked me to come back and talk to the school. And it was the most satisfying, surreal feeling that I've ever experienced. I'm like, wow, this is amazing. So then when I went to JPL, I became the most active member of the Speakers Bureau. I was doing lunches, taking vacation. My nights and weekends were all spent educating. I went to the Rose Bowl and set up a booth on a weekend, and I was in that booth for 10 hours, didn't even get a bathroom break because I was the only one there just talking to all the kids that came by. And I'm like, this is great. How do I get more of this? And what I really realized is that I fell in love with being on the front lines. Yes, I'm designing spaceships that'll eventually go into space and inspire millions of people, but I'm so far disconnected from that process. I like the engaging part of it. I'm like, all right, well, what am I going to do? Well, I decided to leave NASA and create my own space education company and platform where I do a bunch of things. So first off, I'm going to tell you about my mission on that. Don't worry, we're going to get into the sports in a second. But my mission with what I do now is to expose and educate as many people as possible about the wonders of space exploration and its importance to us here on Earth. There's so many people, like in my hometown where I grew up, that like didn't even know NASA existed. My uncle, he's like, NASA still exists? Like, you want to work for them? I'm like, yeah, they're not just the space shuttle. So obviously we know all of this. We're in the industry, but there's a lot of different parts of the country and the world that aren't aware of the things that are going on in outer space. They just get upset when their phone isn't working and the internet's not there. We got to explain to them what's going on and what's the importance behind this. And so how am I setting myself apart? How am I different? Well, my vision is to like bring space down to Earth as literal as possible. And, you know, I do this using props. I got Legos, I got the Millennium Falcon over here. I've got a space shuttle. I use an inflatable solar system that's hanging overhead that I bring with me to pretty much all of the events that have kids under the age of 5th grade. And if we can get people to touch it, to have it be more tangible, it's more of a concrete way for them to relate. Even the people that I've worked with, you know, they're called armchair geologists, right? You don't actually get to feel all of the Mars rocks, or sometimes like even the moon rocks, like you don't get to feel those. We're just sitting in our armchairs doing things. So if we can make it tangible, that is where I see that I'm having the biggest impact when I'm educating out there, inspiring the next generation of explorers. You know, I'm trying to be involved, asking questions, be honest and genuine, trying to avoid like the green screens, be a little goofy, get kind of crazy out there, relate to the kids and make it enjoyable. And if I'm having fun, then it's exciting, it's productive. If I'm not having fun doing it, how is someone else going to be enjoying what I'm doing? And then the big thing I like to do is to try to get space in a place that it's not. And then this is where sports comes in just a little bit. So how am I doing what I do? Well, it's anything space and science. I create and host videos on my YouTube channel, A Place Called Space. And in that photo we saw with liquid nitrogen, I worked for a YouTube channel called The King of Random last year, 13 million subscribers, posting a video a day, doing all these like 12-year-old crazy mad scientist kid things in the backyard, just exploring our curiosity and trying to learn in the process. And I also teach space camps with people from JPL. We've been going to South Korea. They've been doing it for 10 years. I've joined for the last 3 years. Fortunately, COVID put the last 2 years on hold. We go out there, we teach an English-speaking space camp, and then I've been joining Janet's Planet, if you know who she is, Janet's Astronaut Academy around the United States, teaching space camps as well. And then I do after-school programs and libraries. We're bringing that inflatable solar system, and then even Zooming or Skyping into classrooms around the country as well to create the biggest reaches possible, which has been amazing actually with COVID, that I've been able to get into a lot more places since things have been moving a lot more virtual. And then I consult with some media companies, and I do expert interviews and talks like you see on stage there. Now, getting space in a place that's not, this is how the sports come in. So I am an American Ninja Warrior. If you're not familiar with the show, yes, that's me actually on top running back and forth. It's a little gift they created of my first year. I competed on season 9, American Ninja Warrior in LA, which is where I live. And we compete on the back lot of Universal Studios. So you can see there on the top. That's right down the main drag. In 2017, I was transitioning from bodybuilding into more functional fitness. And I'm like, let's do American Ninja Warrior. So that bottom right picture of all of us flexing, that's a bunch of other NASA rocket scientists. So how you get told that you're on American Ninja Warrior is you get a phone call. So they reached out to my mom, who reached out to my coworker, Tejas. He's the one right below me. And he organized a secret lunch on the top of our building where everyone I was working with showed up. And I'm like, this is cool. And then all of a sudden my phone rang and everyone got out their phones to record me getting the call. And then this is a celebratory picture afterwards. Now we will watch this. So it's only 2 minutes. We'll see if the audio comes through too. Show you what it looked like now. I will commentate through some of this. Oh, I need to bring this window to the front. 1 second. Let's see, because I'm sharing a different one. I need to share this one. Yeah, all right, share that video. And here we go. There's all the other rocket scientists that were flexing, hanging out. I'm so nervous right now. I'm freaking out. So this is that GIF you saw in the beginning. The first obstacle, it's a standard one that you always see. So we're 1 for 1. All right, we're doing good, doing good. So that's like the texture kind of a basketball. It's kind of sticky. I don't really remember that part. All right, so these first two spin like actual tires. So you can see them on the axle. The commentating is great by Akbar. And then this last one's like a pendulum, so it doesn't spin, it swings. And that's how it ended. Oh, so what we'll see, I'll just turn off. All right, so you see my foot just touches right there, and I'm like, oh, I can just walk off. I'm tall, I'm lanky, I'm touching, but I didn't have enough momentum. And then right here, the commentator actually says the rocket scientist should have been smarter. And, oh, that just kills me. that comment right there. I'm like, Akbar, you're hurting me. All right, now let me jump back into the presentation here, and we'll talk more about the sports on other places. All right, let's see, we're back here. Lee, just want to give me a thumbs up if we're back in the presentation? Okay, great. So I competed on season 9 and season 10 in LA. That was the first season. I look at my performance and I'm like, oh, I didn't do that well. Season 10, they didn't put me on the air. And something you don't know is we film this overnight. So from 6 p.m. to 6 a.m. is when we're competing. So I'm running the course there at midnight when I'm supposed to be sleeping, getting my beauty sleep, getting rested. I got to be at top physical performance. So competed on the first 2 seasons, 9 and 10 for me. And then I moved into working with American Ninja Warrior. So instead of competing, I work with them throughout the year, testing all the new obstacles. But that means it's confidential and I can't show you anything. I'm up at a warehouse just 20 minutes away from here about every other month where they create new obstacles. And they're like, all right, Kevin, try this out. Is it too easy? Is it too hard? How does it feel? Is it weird? And then you got the producers there. It's like, oh, this looks good for TV or not. Or like I do it and I'm like, oh yeah, that seemed good. I'm like, no, producers are like, we want more people to fall on this. Let's make it harder. Try and skip that part. I'm like, you want me to skip that part? They're like, yeah, go for it. We got mats and mattresses down, so catch you if you fall. So that is amazing. I like everything that you see that's new. I've probably put my hands on at some point over the last couple of years to see how it works once we get to the main stage of TV. All right, now let's talk about space Saturdays. What would I do in space on a Saturday? Well, obviously I would do ninja stuff. So I'm going to talk about being on a moon base and Mars bases, right? Because those are the planets and locations that we are talking about having bases on. I thought about bringing Jupiter into the equation just because of the massive gravity that's there. But realistically, we're not going to put a moon or a base on Jupiter because there's no surface. Could do one of the moons, but let's focus on the more immediate things that could actually be possible, in the next quarter century, half century. We'll see. So we're going to talk about the warp wall and the salmon ladder. Warp wall is the 6th obstacle, the final one of the qualifying course, and you have to run up it, grab it, hit a buzzer, and you're done. Now the salmon ladder, this isn't me, this is Jesse Graff. Supposed to be playing, there we go. And you have a bar that you have to hop up rungs, you have to go up 4 rungs, and then you can transfer over to another obstacle. So what would these look like if we're actually in space on other places training for this? So let's break it down. So here's some conceptual artistry of what a moon and a Mars base could be. So what I'm talking about is we're gonna have to be doing these inside a base. Doing ninja obstacles with a spacesuit, that's just not gonna work. We already have enough problems with like flexibility and moving around with the spacesuits. So we're gonna have to be inside. So really the only thing that we have to factor in is gravity. So what's the difference gonna be? Well, here we go. We got the warp wall. So what does it look like? Well, it's 14.5 feet tall. And then our Earth gravity is 32.2 feet per second. But we're in space. We don't deal with English units. We go metric. So let's convert that over to 4.4 meters and 9.8 meters per second. So if we're going to the moon, that's 1/6 the gravity, which means that the warp wall would be approximately 26.4 meters high, which is 9 stories tall. Now, I can't even really like fathom like trying to run that and make that happen. So we got the 14.5-foot wall. They've upped it to the mega wall, which is 18 feet tall in the last couple seasons. And if you make it up to 18-foot wall, you get $10,000. Now, I've never done this on TV. I've practiced a few of them and tested some of them. Yes, I can make the 18-foot wall. I am 6'4". I'm a giant dude. So I'm able to make that. Now, if we're going over to Mars, we'll back it up 1 second. If we have a 9-story tall warp wall, that means our habitat is going to have to be at least 10 stories so that you can stand up once you get on the top of it. So we're going to have to talk to our habitat designers and make sure we got enough height so we can actually do ninja obstacles up in the moon. All right, now Mars, we got 1/3 of the gravity approximately. Don't hold me too tight on that. I know it's like 38%, but we're talking about 1/3. So that would mean 13.2 meters, which isn't too crazy, but that's still almost just over 4 stories tall. You go outside, you look at a 4-story like apartment building, you're like, that's how big the warp wall would have to be in terms of just relative gravity on Mars. So that's a little bit more believable to create a base. We could do a 4-story tall base and put a warp wall in it. Okay, now let's move on to the salmon ladder. Now the salmon ladder has a lot of specs here. So we see Jesse demoing it for us here again. So each of the rung spaces are 1 foot. The space between 2 sides, so that distance there is 3.5 feet. The double salmon ladder gap, which means there's 2 of them. So Jessie would have to actually jump behind herself 4 feet to go to another one. It's called a salmon ladder transfer. The angle of those runs is 35 degrees, and then they're 4 inches off to put the bar on. But we don't need to change all of that, or like some of it's going to be the exact same. What we do need to look at is the rung spacing, so that 1 foot, because you're fighting the gravity go up, and then the double salmon ladder jump as you're going back to the other salmon ladder. The space between, that's going to stay the same. The angles of the runs, that's going to stay the same. And the length of the rungs, that's going to stay the same too. So if we're looking at the salmon ladder, we got the 1 foot rung, the 4 foot gap. Going over the moon, that's a little crazy. Like just me looking at these numbers, 6 timesing it just for gravity, 6 feet of a rung space, that's actually not crazy. I've seen people on Earth do that. So what they do, instead of having the bar up here, is they go and they put it at their hips, and then like they jump up and they swing. It's crazy. I can't do that move, but I've seen 6 foot gaps done on Earth. So we can do that on the moon. The double salmon ladder gap, 24 feet. Well, based upon the videos we see of the moonwalkers up there, I guess it's possible. You just throw yourself and then you're coasting. It would be a long 24-foot gap to get over to that other salmon ladder. Now, moving over to Mars, we got 3 times the gravity, or 3 times a little bit further because 1/3 of the gravity there. We're going to do run spacing at 3 feet, which I've done that. I've done the 3-foot gap. That's possible. You actually skip a rung. You can go up, you skip 2 rungs, get that 3rd foot. I've done that one. So I got no problem that I'd be able to make that happen on Mars. And then the double salmon ladder gap of 12 feet. That's also reasonable. I haven't done that one. I've done the 8-foot gap. I've done the double 12 feet, throw another 4 feet on there, less gravity. I feel pretty confident, but first we got to get humans to Mars. We got to build this stuff, and then NASA or someone else, SpaceX, Boeing, whoever wants to, throw me out to Mars and let me test all this stuff. I'll do the ninja testing on Mars, get it all good, and then we'll send some competitors out there. So in looking at these moon and Mars bases, we're going to have to do some redesign if we're actually going to want to fit ninja obstacles into this stuff, because the way that we're designing moon bases and Mars bases is for just functionality of astronauts. So we're going to have to step that up once we get to the colony aspect, because we need something to do on Saturdays more than just exploring, plugging in rocks into our spectrometers and seeing, what else is out there. We need some more leisure activities. So that's what I would love to do in space on Saturdays, just do ninja obstacles. So I picked the 2 most famous ones that I think most people may know about, the ones that I think are the most fun. The other ones, not so great, but that salmon ladder and the warp wall, iconic, and would love to do those in space. So thank you. And if you want to see more about what I'm talking about, just see me in Ninja, see me talk about space. I predominantly work in elementary education, creating stuff that's a little bit more kiddie, but also I don't talk down, so you'd be able to understand it as well. And I just kind of have to change the pop culture references for whatever I'm working with. And my Instagram is @Kevin J. DeBruin. That's where I mainly hang out. but you'll see me floating around Twitter, YouTube, and TikTok as well.
Thank you so much, Kevin. That was great. Sounds like a challenging warped wall. Um, we actually had someone speak in at our July event, and they were designing a 25-story Mars habitat inside a lava tube. So you might check out United,
Hey,
yeah, check out United Space Structures, and maybe start talking with Bill Kemp over there.
all right, I like it. I'll reach out to Bill and we'll make this happen.
Yeah, so speaking of making things happen, you demonstrated a lot of tenacity in all you're doing. So when you encounter adversity, you just kind of walk right through it, right? So whether it was getting your internship, getting a job, getting your scholarship and admission to Georgia Tech, or getting the job with Ninja Warrior, after a short run with your own ninja career. Tell me about talking with them about getting that job. Was it because you were an engineer that they were interested in working with you, or a combination of things?
Mostly it was my height. Mostly it was the height. So like the perfect, or I guess ideal ninja competitor is about like 5'7" to 5'8", but they do have some really big guys who compete. I was the tallest person to compete in LA the first year I did, but then they had a 6'7" person compete.
Yeah.
So when you're looking at designing obstacles, and this is where like the engineering comes into it, is that like the difference in designing it for a 4'8", 4'10", a 5'7", and a 6'4" is completely different when they're doing gaps and stuff. So they're like, well, can you make this jump? Can you reach this thing? So it's predominantly based upon the height, but also because I was working with them in the off season, they do a ninja versus ninja competition. So that's where there's two courses right next to each other, and they run. I wasn't competing on that, but I was asked to test for that with a couple of friends. They're like, oh, hey, you've gotten a lot better since competing on your first season. Do you want to come and work with us to do these long-term goals? And whenever I want, I can step away from that for a year and then compete again. I just have to be gone for a year so I can come back.
Okay. That's fun. Well, my kids are big fans. So, let's see. So last time we learned that Duran Duran and Farrell are very into space. And so were there any
Oh.
particular other ninja warriors who just wouldn't leave you alone because you worked for NASA and were a rocket scientist?
Funnily enough, it wasn't leaving me like super interested in space. What I got was a lot of conspiracy theory questions,
Oh,
which,
really?
yeah, which is like, okay, like this is my thing now, right? I'm a science communicator. I'm trying to educate. So people asking questions about flat Earth, about UFOs and aliens and NASA lies. Right now, I'm in an environment where that mentality is a lot more prevalent, and now I'm seeing as a source of information to deter those thoughts, to give the
Yeah.
evidence, to explain to them what's going on. There was also one person that I was training with for a year and a half before I found out that he was a Boeing satellite space systems engineer. And I'm like, dude, how have we not like had nerd out conversations about spacecraft design? We've known each other for a year and a half now, and we just learned that we're both rocket scientists. Like that's a little crazy.
Oh man. Yeah, debunking is just as important as sharing new information, really. So
Yeah,
that's important work.
yeah. I did.
So yeah, go ahead.
I will say that there's so setting myself apart from the rest of the ninjas, like being known as the fit rocket scientist at that time. I got introduced whenever I met somebody new as, here's Kevin, he's also a rocket scientist, which
Yeah.
was nice because I don't have to bring that up myself, because I feel weird sometimes. We're like, hey, I'm a rocket scientist, but like getting that introduction, at least putting it out there, and then some of the people were like, okay, yeah, whatever, but some are like, oh, cool, dude, like I like this, and it was able to spark another conversation. So getting known in that community as, the rocket scientist was a good thing to just kind of like cut that barrier out and then make it immediately accessible to anybody else.
Yeah, good gambit to break the ice. So one of our earlier speakers today talked about where he sees a gap in critical thinking skills and problem solving in college-aged kids. You are working with elementary aged kids, and you may not have seen a lot in person in the last year, but certainly have interacted and continue to make videos and work virtually. Tell me about your experience with that age group. Are you seeing that? How are children different? And what solutions are you working on?
What I see as the biggest thing is like when they hit fifth grade.
Mm-hmm.
So up until fifth grade, it seems like they're not as corrupted, is what I'll say. Not as corrupted by like their parents or the media or social media or pop culture, where there's still these sponges who are absorbing things, who are asking questions, who are interested, have been beaten down by society or by bullies or peers or anything like that. Really in the third and fourth grade. And that's why I like to focus on that, is because I guess it's easier, it's more fun. I can really pull out my inner child. But when I'm talking to fifth grade and above, so like fifth grade to eighth grade, when I'm doing like the middle school thing, that's where I'm starting to see a little more jadedness, or a little more let's goof off, or let's not pay attention, which is interesting. Like I go to a Burbank middle school every single year. That was the photo of me with the selfie, and there was like 600 kids behind me. And that is a great example of how the middle schoolers are a little bit edgy in the beginning, right? And something that I can use as American Ninja Warrior sets me apart. And like, oh, like once I bring that up a little bit into the presentation, it like knocks down the barrier of, oh, this guy's not just a nerd. He does something cool and we can listen. Well, what I've also noticed, besides just the ninja part, and like when they're forced to be in a room for, you know, an hour with me, after about 15 minutes, the edginess kind of drives off, and then they start to get interested. So as long as they're kind of like forced to sit there from like the fifth to eighth grade range, I can grab them, right? I need a little bit more time with them to really pull them in, because they've got so many other things they would rather be doing, because most of them have phones. Even the third graders have phones at this point. But that's what I've really noticed, is I need more time with them in a forced situation, or I start with something that's not space at all. The first thing I put up is the Ninja Warrior video and be like, yeah, this is me. All right, now let's talk about space. It breaks down that barrier. So I need to find a way to hook them in that has nothing to do with what I'm actually talking about.
Yeah, good strategy. And I guess one last question. You mentioned that you're from small town Wisconsin. And it just turns out that one of our judges for tomorrow's business plan competition is from Mequon.
Yes.
And so we're seeing these small towns. We've hosted this event from Akron, Ohio, from Savannah, Georgia, which are a little bigger towns, but still sort of not what you think of as sourcing space experts and people. Talk a little bit about workforce development in those terms and the opportunities that you see in the industry for people growing up in small towns.
I think what's critical is to see an example that it's possible. I think is to really put it out there, right? Like no one in my hometown thought it was possible, or at least no one told me. Everybody laughed. They didn't see it as something that was achievable because it was so far away, right? So like bringing these competitions to the small towns, like I didn't have any like FIRST robotics and stuff growing up. Maybe it's in the area now, but I had nothing space oriented. The closest thing we had was the EAA, where they had Spaceship One in there, and that was amazing in Oshkosh. But besides that, there was nothing in the small town that like hooked me in. So if we're trying to develop that workforce in the more rural areas, or in the areas that are more disconnected from being actually in the space environment or space exposure, like I didn't get to see rocket launches just by looking out my window, like so many people have who live in Florida that I've spoken to over the years. So that's where I'm still trying to get space into places it's not. Like on the coast, we're good, right? In the cities, we're doing okay. But when we're going into more rural options, that's where we need, like, essentially, free education, right? Like PBS is a huge thing that Mr. Rogers fought for as they were trying to take that off. And he's like, no, we need this free education. We need it easy and accessible. And with the age of social media, that's great. Now we can reach kids or individuals in these small towns with free access to education. And that is the thing that we need to do, is be able to get the space into places it's not, show that you can do these things, show that as an option, and highlight some people who have made that journey. Like Emily Calandrelli, also known as the Space Gal, host of Emily's Wonder Lab. Like she came from West Virginia, right? And she's constantly highlighting that to show, hey, you can go from that to out here. Now she's living in Los Angeles doing tons of science hosting stuff as well. Just continue to share these success stories of people who come from these small towns that are able to make a difference in the world of space.
Thank you so much, Kevin. It's been a delight to have you on.
Thank you, Lee. Appreciate it.
All right. Our next speaker is Eric Ingram. He's the founder and CEO of Scout Inc., a company de-risking space operations with sensor suites that enable spacecraft to see and understand the area around them. He also currently serves on the board of directors for the Space Frontier Foundation. Eric was previously an aerospace engineer for the Licensing and Evaluation Division of the FAA's Office of Commercial Space Transportation, where he gained expertise in the regulatory environment. Prior to this, Eric was an engineer for Deep Space Industries, where he designed CubeSat systems for testbed missions. Outside of the space industry, Eric previously served as the president of the United States Wheelchair Rugby Association, leading the USWRA to its largest budget surplus in its 30-year history. Eric has competed in the sport of wheelchair rugby for 15 years, competing domestically for several club teams and internationally with the U.S. development team. Eric holds a Bachelor of Science in Physics from Old Dominion University, most of a Master of Science in Electrical Engineering from the University of Houston, and a Sport Pilot Certificate, and is working towards his scuba certification. And in your free time, Eric, thank you for being here. Appreciate your time.
Yeah, thank you for having me. And I'm definitely interested in talking about like the intersection of sports and space, Kevin. So reach out, we can have a whole sidebar about that, given both my athletic experience as well as my space experience. So let me share my screen here. I'll first kind of talk about what we're doing as a company, then kind of dive into, I guess, the workforce part of the equation, then happy to just do Q&A, whatever works. So as was mentioned, my name is Eric Ingram. I'm the CEO of Scout, and we are a company developing vision systems to help de-risk the space environment. So spacecraft today are literally flying blind in an environment that is increasingly congested and contested, and the number of spacecraft in orbit will be going up 30x by the end of the decade. We founded Scout in 2019 after my CTO lost his spacecraft to unknown causes. And so his team spent 5 years and millions of dollars working towards developing the system, only to have it dead on arrival in orbit. And there was really no way to figure out why. And, you know, one of the theories that went into trying to solve this thing is if we just had a picture of the spacecraft, we'd be able to at least probably diagnose what's wrong with it. And that was in 2017 with, you know, the environment as it was then. Looking forward, it's going to be a very crowded environment. The number of conjunctions, which is possible collisions, is going to be going up exponentially. I think last year, the number was about 400,000 conjunctions that occurred. Obviously, there's different probabilities with those, so not all of them are ones that require analysis, but that number is massive. And ground-based sensors that we use today, which are great, won't really be able to keep up with that level of activity. So another thing to add on is about half of spacecraft failures never have a cause determined. And there's very little we can do beyond the telemetry we get down to diagnose what's wrong. And if the sensor is part of the system that is causing the problems, it can't be trusted. And with spacecraft, sometimes the size of a school bus, it's hard to have a sensor on everything. So having other ways of verifying what went wrong is going to